Ignition sequence start. 3, 2, 1.
Houston, we have a problem.
Liftoff. We have a liftoff.
We copy you on the ground. You got a bunch of guys about to turn blue.
What you're seeing here is a mirage.
Are you ready? Debate fans, are you ready? For the handful in attendance and the thousands watching across the world, brought to you tonight by Jeranism, the #1 YouTube channel in all of existence. Ladies and gentlemen, let's get ready to rumble!
Make sure your argument is tight. Babe, what? You must got proof if you so right. Babe, what? Don't get dismissed on false claims, cause you gotta bring the truths and the facts. It don't matter if we talking about racism, sexism, scientism, paganism, socialism, communism. Talk about capitalism, atheism, globalism. What about creationism? It don't matter what the ism. Live on Debatism.
Are you ready? It is time for another episode of Debatism. Let's hope it's not the same as last night. But we've got episode number 12. It is Professor Rob Parks, PhD, versus Austin Whitsitt in a Shape of the Earth debate. Let's bring them on, see how everybody's doing. Welcome to the show, guys. Let's first have Rob. Go ahead and tell people who you are, and we'll get going.
Howdy. My name is Rob Parks. I go by Professor Parks PhD on my YouTube channel, where I put forward astronomy, mental health, and science skepticism content. I have a doctorate from Georgia State University from 2014, and my research interests include young star formation, planetary exoplanets, and stellar magnetism. So that's me in a nutshell. I also like long walks on the beach.
Thank you for sharing that. And we're happy you're here. Thank you for joining us. And we've got Austin. Austin, I'm sure everybody knows who you are, but you can go ahead and say hello.
Hey, how's it going? Yeah, I am Austin.
All right, good to know. All right.
Yeah, Whitsitt gets it on YouTube. Just didn't finish college. Don't do anything professionally in these fields.
What are your credentials?
I like to discuss them anyway.
Okay, let's see here. I'm going to make sure that everybody in the chat sound is good. Everybody can hear everybody okay? Let me know that, and we will get going. I'm going to do a coin toss real quick, and then you guys can do, or we'll pick who goes first for the little intro. Let me bring this screen up over here, and we will do a coin toss. You can see this, I hope, both of you. You should be able to. Oops, move it a little bit more this way. Yeah, maybe a little more. There we go. All right, so go ahead and call Rob, since you're the first time here. Let's go ahead and do that. Ready? What do you want? Heads or tails? He calls heads, and it is tails. So, Austin, you want to go first or second?
You can go first.
Okay. 3-minute intro just to lay out your case, and when you're ready, we will get the clock going.
All right.
I'll start when you're ready.
Howdy. So my position is that the Earth is a sphere of roughly 65 yada yada. We all know the miles. The Earth is a sphere revolving around the sun. The moon is revolving around the Earth. We are part of a planetary system with a G2 star at the center, and that planetary system is moving around the core or the center of the Milky Way galaxy at a clip of 220 kilometers per second. Today, we're going to be talking about whether or not the Earth is, in fact, a flat, stationary plane as opposed to a globe. There are numerous things that I can choose from, including stellar spherical excess, earthquakes, things of that nature, to propose the argument, stellar aberration to show that it's moving. But I'm going to focus on sun angles precession to illustrate that the Earth must be a globe, and I'm going to be talking about how the orbits within our solar system and how they are observed and how well they are observed, along with the idea of barycentric correction for eclipsing binaries and spectroscopic binaries, how that is necessary in order to properly analyze these systems. And that requires that the motions of the Earth be taken into account. So therefore, the Earth cannot be stationary. There has been some idea put forward. You may hear about the neo-Tychonic system. The neo-Tychonic system claims that there is a equivalence between putting the Earth at the center of the things and where we versus anywhere else. To a certain extent, that may be true. However, I have certain reservations about relational mechanics, namely two of the postulates, the most glaring of which is that the sum of all forces in a system must equal 0, including if only one force is active. So I hope to be able to show that through the use of sun angles, through the use of simple geometry, a flat plane is inconsistent with the altitude of the sun at certain points. I would like to show that the precession of the Earth, which we see through the movement of the vernal equinox, also cannot happen from a geometric standpoint due to on a flat plane. And like I said, I will go into how the positions of the planets and how the distance to the sun have been measured relatively recently and how they are measured now. And I think that's probably under time.
All right, yeah, you made it by a second. There you go. Thank you very much. All right, Austin, you're up when you're ready. I will start the clock.
Okay. Yeah, so my position is, of course, that the Earth is a geocentric stationary plane. Or geocentric means Earth centered, so the universe would be that. Yeah, and that's the default position based on all empirical evidence. So let's see. Basically, I want to discuss how heliocentric proponents somehow think that it's legitimate to ignore the insurmountable amount of discrepancies in the heliocentric model. Every time I have this discussion with people, they say, oh, but it works on the solar system scale. Like, well, it's not 1600, so we're not going to just talk about the solar system when Newton thought that the sun was in the center of the entire universe. When we look out to the rest of space, as it were coined, we see major problems with the heliocentric model, mainly that the universe must be accelerating and expanding in all directions 4 to 8 times faster than the speed of light, and that there's no known energy that could even cause that to happen. There's no detectable, observable evidence that that's even the case. That is a big deal because, of course, a geocentric position wouldn't need that accelerative expansion. So that means it would be more viable, right? So these arguments of simplicity or elegance or preferred mathematical deduction is all irrelevant. So yeah, I mean, I'm sure we'll get into a bunch of the typical things: parallax, aberration, retrograde. He mentioned a few that seem new, so it should be exciting. Then as it pertains to the rotation, we've done interferometry measurements at different altitudes and different directions. And we've shown that the interferometry, meaning the propagation rate of light, has a preferred direction. So light is not constant, C is incorrect, it is not invariant. We've shown that it changes with altitude and it changes with the time of the year and even the day or the time of the day, all of which refutes the notion that the Earth is in fact a spinning sphere, causing the Sagnac effect or causing what we detect in relation to sidereal rotation. And then when it comes to the curvature, you get straight to the falsification of the radius. It doesn't matter if people came up with ideas when they looked at the sky and they said, look, this works with my math if I assume the Earth's a sphere. If we falsify the radius value, all of that can just be thrown away. And we've done so, and one of the main ones I'll bring up is how we shoot radio waves over 100 megahertz frequencies, far over the physical limitation of a sphere, which should block them anywhere from 30 to maybe 100, 200 miles. And they go over 2,500 miles, falsifying the radius, thus falsifying the entire model. So in summary, my position is that, based on all empirical evidence, the Earth is a geocentric stationary plane. It's significantly more viable than the heliocentric model. And yeah, we don't get to pick and choose what evidence that we look at. And reification fallacies and presuppositions are not going to be a sufficient counter. to that evidence. So that's pretty much where I stand.
All right, excellent. Thank you very much for that. That was the openers, so that you guys heard those. Coming up next, we've got some questions and answers going back and forth, and then we'll get into some claims. If you have a question for either of these guys, you can send a super chat, or you can send a tip on Rockfin, and we'll get to those at the very end. So that's the way to go about doing that. We'll catch those. And if you're interested in debating, you can either go to t.me/debatism, or you can email us at debatism@outlook.com and let us know what you want to debate. And if you've got somebody to go against, let me know, and we'll get you scheduled onto the schedule here. All right, so the way the questions is supposed to work, and by the way, thank you, Rob, for stepping in last minute. If people don't know, it was supposed to be
no problem.
Craig from Fight the Fat Shirt, but he had something personal come up, so he couldn't do it. So we asked Rob kind of last second. So he is not really familiar with the layout, and neither really is Austin. So the way it's supposed to work now is you get a minute to ask him a question, anything you want, and then he's got a minute to answer. And if you guys want to go back and forth on that, if you need to, we can do that for a minute or two each one. But basically, you're supposed to ask 3 each. So Rob, you go ahead. You can ask Austin anything you want. Probably.
Okay. Well, first I want to make your position clearer, because flat stationary plane is a little bit ambiguous. So my first question is, what are the physical dimensions of the flat plane? How big is the flat plane? What's the mass of the flat plane? What are the physical characteristics of the flat Earth? With error bars, if possible.
Okay.
Well, mass is actually undefined conceptual quantification that isn't even agreed upon. It's volume times density. I would never know what the density of the Earth is. That's an absurd request. I also don't know the dimensions of the Earth. You can't privately explore it past 60th south latitude. And actually, it's monitored within the 55th north latitude since like the 40s. So I don't know the dimensions. We've never gone deeper than 7.8 miles. We can't independently verify much higher than maybe 60 miles, 70 miles. So I'm not going to make dimension or mass claim, as the counter argument consistently has to shuck and jive and make up new claims about those things. In fact, my worldview says that it's physically impossible to know those characteristics. So I don't have an answer for you. And in 1776, the king gave a decree: you can't even make a map without using the longitude and latitude coordinate system of the presupposed globe, which is why we don't really have functioning maps from a plane perspective. So I cannot make those claims. That information is not accessible.
Okay. Any discussion there, Rob? Are you good?
Oh, yeah.
Okay.
So I've never heard the claim of the king from 1976, but in this country, we fought a war against a king, and so we won. So why is it that, my question would then be, why is it that we still hold to that? Two, we can get into the terms of mass, but you say that asking for the density of the Earth is a nonsensical question, and your worldview is that it is impossible to know that. So I would really like to know why that's the case, or how that's the case.
Yeah. So I wouldn't make this a claim and as much of a debate type of argument, but the scriptures say that as soon as someone's able to fully measure and know the dimensions of the Earth or the depth of it, that's when the Creator will turn his back on his people, which is a way of saying that no one will ever do that. So, the scriptures say, I can't remember. The scriptures say that you're not going to be able to measure the Earth. But that aside, right, which would be like my worldview, my spiritual worldview. I don't think that you can figure out these things. Again, mass is volume times density. We don't know the volume. We just covered that. Never gone deeper than 7.8 miles. One would logically assume it goes deeper than that. So I can't get volume, of course, being linked with breadth, right? Like I can't know those things. And then it was 1776 they gave the decree. For example, the Gleason map that all the flat earthers use, Gleason wrote it to his friend and was like, hey, by the way, the Earth is not a spinning globe. That's ridiculous. Well, my map is within the confinement or restriction of this longitude and latitude coordinate system because they won't let me patent my map otherwise. And if you think you're going to have any success publishing or patenting a map nowadays that doesn't use the longitude and latitude coordinate system, you're going to be in for a rude surprise. So that is when everything turned left But yeah, so there, I think those are your questions.
Okay, Austin, your turn to ask the question of Rob.
Okay. So a bit of a left turn here. So I'm gonna preface this with a hypothetical, right? So it's a hypothetical preface of if, and I think I may have asked this question before, but if there were a kinematic and dynamic equivalence, and of course, kinematics, the way that bodies move in relation to each other, dynamic, the force that causes it to do that. If there were a dynamic and kinematic equivalence and validity between the geocentric and heliocentric model, we could just say simply, we are able to explain astronomical observations from a stationary, like geostatic position. But the geocentric position wouldn't have the issues of dark matter and definitely not dark energy. Wouldn't that mean that it is significantly more viable in the heliocentric model?
Okay.
That is a hell of a hypothetical. But what I would say to answer that, and let me be careful on how I phrase this, is if there is a theory out there that can explain everything that we can currently explain using classical mechanics and relativity, where the Earth is the center, is the physical center of the universe, and it can solve the discrepancies, or not discrepancies, it could answer the open questions of what is dark matter or what is dark energy, then obviously, yes, we would, that theory would need to be considered strongly.
Just to clarify, not answer the questions of it. It just doesn't have to answer that question, right? Because it wouldn't need accelerative expansion, etc.
Well, okay. So, I mean, it basically would have to, when I say explain the questions of dark matter, we do have a missing matter problem in terms of our own galaxy and other spiral galaxies. So whatever theory this happens to be needs to be able to explain where that missing mass comes from, why do we observe this missing mass.
Yeah. I'm by the way, Jaron, I'm gonna immediately forget the format. I don't really know what it is.
No, right now we're just.
I'm naturally just gonna want to go back and forth. I don't know how it's supposed to work.
Yeah, I mean that's the questions. If there needs to be a back and forth, there can be.
Okay.
So you can go back and forth on this one for a couple minutes.
Yeah, I mean, obviously, dark matter is going to be like a rabbit hole that we get into, and maybe we can discuss that. I guess just to make sure we're on the same. But like, my question is, if there's a kinematic and dynamic equivalence, and your position is, well, that's a hell of a hypothetical. I get that. You can certainly get into that if that's true. But then if we, like, for example, we don't need accelerated expansion if the Earth's in the center, right? We would have maybe to come up with an alternative explanation for redshift. Well, we wouldn't need the belief that there's accelerative expansion, right? That's needed to explain why it makes look like we're in the center when we look out in space. And what I'm saying is that's a huge problem, and so is dark matter. Like you said, you guys have a missing mass problem. I don't have that problem, and those two combined make up 96% of the universe, and 83% of all matter is dark matter. And we're off by 10 to the 120th power when we apply vacuum this cosmological constant problem that you have. So if there's a model that can explain astronomical observations that gets to do away with those major glaring issues, doesn't even have those problems, I mean, I would say that it is significantly more viable than the system that is basically pigeonholed within those problems, right?
Yes, any honest scientist would agree with you on that. The question that I have is,
do you want to
how a geocentric model would not require an acceleration of the expansion of the universe? Essentially, my question is more how is heliocentric or geocentric related to the expansionary universe? Why is it that you can have one without the other?
We'll go ahead and call that your second question.
No, sorry.
That's all right. That's good. Moving along, fine.
And we can just kind of go back and forth towards the end or something, right? I mean, it's all good.
Yep.
And to tell the audience, like, dude, Professor Parks was a legend and took this debate like last minute.
Yeah.
So I kind of reached out to him. I agreed. I'm like, bro, I'm not gonna come at you with like a full like ammunition or something. Like we're just. So anyway, there's a context. Okay, so the difference is that you go back to like Hubble, right? We started making deeper observations or whatever, deeper in space. And we saw that distant galaxies moved in relation to the Earth, for example, like, right, they would complete a circuit, they would appear to complete a circuit like once a year and stuff like that. And that wasn't expected. And so far beyond our galaxy, which people were trying to figure out what even is our galaxy, what are galaxies, are there other galaxies, where are they, right? This was like that moment that we didn't know anything. Everything looked like it was moving in relation to us. So the accelerative expansion helps to answer that question, as in, well, yeah, sure, it creates the illusion that we're in the center with everything moving in relation to us, just because from our little minor vantage point, everything's inflating, or more so expanding, accelerating. So it looks like that. Well, the geocentric position would say, oh, well, it looks like we're in the center because we're in the center. And so we would have redshift that we could acknowledge. We wouldn't need accelerative expansion, but the heliocentric model, would you agree, absolutely requires the universe to be accelerating and expanding, or it would be immediately falsified, right? It would put the Earth in the center.
The current cosmological model states that everywhere, if you are anywhere in the universe, it would appear as if everything is expanding away from you. And you can look at, you can do a geometric sort of analysis to see that. You can actually, there's a, not to get too far into it, but you can do this yourself. Take a balloon that's partially inflated, put dots all over it, measure the distances between the dots, inflate that balloon to a certain size, measure the distances again. And what you'll find is that relative to each point, it appears as if the universe is getting larger from that particular position. Now, when you say that the geocentric model would eradicate the need for a accelerate or expansion in universe, I still don't see how the geocentric universe deals with redshift. How is it that, okay, so what that would say is that the geocentric universe, the Earth is the absolute center of the universe. And so everything is still expanding away from it. So what about that model solves that problem?
Yeah, so that's your interpretation of redshift, and it's been falsified. Halton Arp has done plenty of work on how it's been falsified. It's pretty extensive. I know you've heard of him, but I've never heard people, but have people sufficiently rebutted each of his points is a separate question. And I've never heard them, but there are many anomalies, and this is the convenience of the heliocentric model. They get to just call things anomalies. And that's kind of was my point in the opener. Well, one model doesn't have to make up all kinds of crazy things that can't be tested, falsified, or whatever. But yeah, redshift would be an observation that needs to be explained. But actually, we could explain it better because we're not limited to this equidistant accelerative expansion that is going 4 to 8 times faster than the speed of light, right? Because now people are thinking it may even be up to 8 times faster than the speed of light. You need an immense amount of energy that no one can find to even make your model theoretically possible. Redshift could be the centrifugal divergence of a magnetic field because we have electromagnetic retardation, which causes red and blue shift that can be replicated in a lab. There's obviously, I'm sure you've heard like the tired light theory, right? But the idea that there's attenuation of the light as it travels, quote unquote, which light doesn't travel, through whatever the medium is. There could be plasma causes redshift. There are many different things. This would also be a better explanation because of things like supernovas, which have way too much redshift, or how we observe certain stars that are way closer that have more redshift than things further away. Same with the supernovas. You guys have discrepancies, assuming that it's just based on basically a Doppler effect, whereas alternative explanations wouldn't have that problem. So it would actually be better at explaining redshift, and we wouldn't have the dark energy problem. So our position is pretty objectively more viable, I would say. Yeah.
I would need to know what your full position is. At this point, you're talking about a hypothetical geocentric model. Can we narrow this down a little bit more? Can we say the neo-Tychonic model?
We can say the neo-Tychonic model if for intents and purposes. I wouldn't, gun to my head, I wouldn't think that that's the exact model, because it's only needed to explain stuff like retrograde, and in reality, you don't need that to explain retrograde, right? We just look at the motion of the planets in relation to the background stars, and so they could slow down. They could literally just slow down. But sure, the neo-Tychonic system is fine. I've invoked that to explain the kinematic and dynamic equivalence with the Newtonian and Einsteinian mechanics, neither of which do I adhere to. I don't really feel the need to replace it. Like, let me make this point to you, right? Like, you want me to narrow it down, and that's cool. But you agree that within your own paradigm, you don't have it narrowed down either, right? Like, and this is with the world's funding and universities. I mean, there's over 200 variations of modified Newtonian dynamics published on NASA's, own website. Like you guys have no idea what's going on. You guys are still speculating. Someone just speculated that the universe is actually 26 billion years old. So I don't think I need to answer it all. I just want to kind of focus in on the fact that you guys need dark energy that can't be found. We don't need that, so that makes our position more viable, unless you have some like damning exclusive evidence that would nullify it, right?
See, you claim that you don't need it. However, I have yet to hear what your model is. You say that you can't pick and choose. But when you just spoke about the Tychonic model, you said, I believe in the equivalence, but I don't believe in like the GR and other things about it. To me, that sounds suspiciously like picking and choosing. I need to be able to see a cohesive theory that can be explained and mathematically can be shown and tested through various different experiments to entertain the notion that this geocentric model does away with the explanations for dark energy and dark matter. In terms of our whether or not we have a cohesive theory, we do. It's called general relativity. Now, general relativity has open questions, dark energy being key among them, at least in my opinion. And there are alternative theories about whether or not general relativity can be falsified. But the way that current science works is that things like MOND, when they are developed, they have to follow the criteria that they can not just explain why dark energy or why the observations which lead us to believe that dark energy is a thing, can explain those observations. Why is it that the supernova A1A or this type 1 supernova type 1 supernovas are at some distance, and that sort of thing. So far MOND has not been able to do that, and in fact it has been in recent events or recent discoveries, it has been shown that MOND still needs dark matter in order to properly explain our current universe. I do want to address one other point that you have said a couple of times, and that is with the inflationary period of the universe. Yes, the inflationary period of the universe is also somewhat problematic, and in that, as far as I'm aware, we do not have a great physical mechanism for why it did that. Really, it is just a way to explain the anisotropies within the CMB. But to say that it expands greater than the speed of light is a misunderstanding, because in that context, that would require a frame of reference outside of the universe, which is physically impossible. And so when the inflation occurs, not just the space expands, but also time expands. And so the speed of light is still constant, even though the volume of the universe is 50 orders of magnitude over a very short period of time. It's because all of the dimensions, because you have to remember that there are 4 dimensions and they are all linked to one another.
Yeah. You want to go with your second question, Austin? Or you can keep going on this one if you need to. But you can,
sure. All right. Yeah, because we'll just move on from that, right? I mean, it's whatever. My question was pretty straightforward. So my second question, I guess, would be, do you agree, because obviously to claim that we are in fact a globe that's spinning, revolving, and in this ever-expanding magic universe, that each one of those components need to be true. Like, you can't pick and choose, right? Like if it's spinning, it has to be revolving, for example. So would you agree? I guess my question is, do you agree that if we say use a gyroscope or interferometry to detect this alleged rotation of the Earth, that the drift, right, or the fringe shift detected because of the assumed rotation of the Earth, that effect must remain the same at the same latitude, even if you change altitude? Therefore, my real question, I guess, would be, do you agree that if you were to show a fluctuation in that effect, increasing altitude while maintaining the same latitude, that would actually refute the claim that it's Earth rotation, thus refute the claim that the Earth is a spinning globe?
Sure. Do you have that evidence?
Yeah. We have like 20 tests that have done this.
Can I see one?
Yeah, sure. I'll send you the whole list. Have you ever seen the list?
I don't believe I have.
Yeah,
I know that Icon Science that has been wanting to have a live stream talking about apparently some kind of shift in the speed of light in GPS systems.
Yeah.
And I think that's the only thing that I've heard even remotely akin to this.
Okay. Yeah, that's a bit different. But yeah, I have a list here. But I just want to make sure we agree on the principle, right? Like, because it would stay the same at the same latitude even if you change altitude, if it's a spinning globe. And
yeah,
right. Yeah. So the globe's been debunked then. I mean, this has been done with millimeter precision with radio waves in 2004, 2015, 2020.
You say that, but I am suspicious when you say that.
I don't blame you for finding it suspicious, but so or do you want to go through the paper right now? I can send you this whole list of papers actually.
Yeah, and if we don't need to go through the entire paper, it just if you could show me, if they have a data table that shows me what the angular velocity of the Earth is as a function of altitude or a graph, then I think that would be pretty clear.
Yeah, I'll have to find it here.
And that's good for the second question. I'll call that kind of done, and then you're going to get them that paper, right? So, Rob, you can ask the next one if you want. Your third.
Okay. I think I already know the answer to this question, but how do you define flat in relation to what reference frame? And so when I think of flat, when I think of anything, I think of a value, and then that value is measurable, and that measured value has an error bar to it. So how are you explicitly defining flat? And how has that been measured? And if it has, what is the precision of flatness?
Yeah, so flat's just a general description of a surface, right? I mean, it's obviously no flat earther thinks the Earth is like literally flat. It's a topographical plane. But yeah, we have, I mean, all survey measurements in the entire world have measured the Earth to be flat. What we then do is we use geodetic surveying to take those plane survey measurements, put them together, look into the distance, and then get averages based on our ellipsoid assumed model. But I would say that the most precise way, and this could be called a measurement as well, is radio waves. Because, of course, we know the distance that the radio wave propagates. It would actually fluctuate a little bit. And you brought up basically the variance of C when it comes to GPS, right? A preferred direction. So, for example, if the quote unquote speed of light was a little different, then your distance would be a little off. Okay, and that's being really tedious there. But nevertheless, it's effectively a measurement, right? We have shot line of sight horizontal radio wave propagation way further than a spherical Earth would allow, and that would be measurement of flatness, right? If the surface isn't curving, then it's flat.
I wouldn't say so. When I'm thinking about this, so for Earth, for example, we have the infamous 8 inches per mile squared, and so for me, what would be a measurement would be to test. No, in fact, the curvature of the Earth is 0 inches. It's that value is 0. There is no measured 8 miles per 8 inches per mile squared. That the deviation is 0. That would be measurable, and in my opinion, and again, it would be measurable with an error bar, simply stating that we see too far, whether it's radio waves or whether it's optical observations. I discussed this with Dan at length, and I don't think I got through to him. But what I would be convinced why is that you need to show what the expected distance is given our current understanding of physics, and then showing that. So when you say that it's too far, like I know you're talking about radio waves, but with the salt flat observations, they see 24 miles. That's great, but if you can tell me what you would expect to see on a globe, given all of the variables, and you find that is in fact 20 kilometers or 20 miles or what have you. If it's shorter, then great, then I will pay attention. But just simply stating that it's too far based on a simple metric conception, not enough.
I didn't mean to step on you, bro.
Yeah, no. Go ahead. I'm done.
Can I share my screen real quick, Darren?
Yep. Go right ahead.
I'm going to show you a bit of what I'm talking about. We're good?
Yep.
All right. We covered this in Skull and the Glovers last night, right? But
yeah.
So obviously, the higher the frequency, the higher the attenuation rate. 1901, Marconi sent radio transmissions over 2,000 miles. People told me he wouldn't be able to do it because the curvature of the Earth would block it at under 200 miles. And that's just a quote from the History Channel's paper, because actually it would be under like 19 miles at 330 feet. At 330 feet, the height of the tower, then it would have been under 19 miles or whatever it was. So, long story short, because the curvature of the Earth would actually block the radio wave, right? Because if I send it out line of sight horizontally, then the curve of the Earth will block that line of sight transmission.
Is that a geometric argument, or are you including refraction?
The geometric argument, because you can't invoke refraction for skywave propagation frequencies. So they do invoke it in your paradigm for ground waves, and they'll say there's some refraction and that it basically contours around the globe, and then it diffracts as well. But when you start to get into higher frequencies, you can't really do that. But just
okay,
this is where we came up with the ionosphere, right? Because they're like, oh well, the curve should have blocked it. So how did it get there? Well, it must have kept going towards space and reflected back down. Okay, fair enough. For intents and purposes, which I don't believe in that claim, but we're going to grant it to the globe. Okay, they say that the ionosphere has a frequency range of 30 to 40 megahertz. So as here, this is from Encyclopedia Britannica. VHF signals with frequencies above about 30 megahertz usually penetrate the ionosphere and are not returned to Earth's surface. If it tops out at 40, simply any frequency higher than that's going to penetrate it, right? Okay, well, here are the world record of amateur world record radio transmissions, and these are over 100 megahertz. That's the frequency here on the left, and they've been shot over 2,500 miles at times. Well, just a few hundred feet tops off the ground. Now, these all vary at height, So the Earth's curvature should block this 30, 50, maximum 200 miles away. It's been shot over 2,500 miles multiple times. And it can't bounce off the ionosphere because it's almost 3 times higher in frequency. So that refutes the claim that the Earth is a sphere. This is a geometric physical refutation. We don't have to worry about optics or anything like that.
All right, so a couple things. One, not that I don't trust you, but where is that source from? I want to verify that is 106 megahertz as opposed to 106 kilohertz. And the other thing is, can you go back to, I'm honestly not overly familiar with radio waves. So I was unaware of, under normal isotopes, is the highest frequency wave that can be reflected from the ionosphere.
Yeah.
Okay.
I'll happily send you all the, I'll send you all the interferometry papers, and I'll send you that list of all the, it's 100% megahertz.
Okay. All right. Yeah. Like I said, it's not that I don't trust you. I just trust but verify, as Reagan would say.
No, yeah, that's cool. I'm trying. Here, I'm gonna stop sharing.
Okay. And Rob, you can ask your next one if you want, whenever you're ready. Or you can keep going.
Well, it's funny because that kind of was gonna be my next question. I mean,
which works.
Yeah, I guess what I can do is I can pull you into gravity land. So, because we kind of talked about, I mean, that refutes the globe geometrically. I get that you want to keep investigating it, and that's cool. And I think we're going to try to do some more tests, and hopefully maybe you'd even want to be a part of it, and maybe some people that have expertise in that field or something. Anyway, that refutes the globe, as do microwaves. So the next question, the glaring question, because we kind of talked about motion, geocentric, interferometry, debunking the rotation. We've talked about the geometry refutation of radio waves, microwaves, amongst many other things. But the next one, the big claim, right, is that we're in a giant vacuum, this majestic vacuum of stars and all this stuff. And so, and I know you've heard it. I know you've heard the question, but how do we have a pressurized system within a vacuum of 10 to the negative 17 torr, applying the second law of thermodynamics, which is, of course, that natural and spontaneous systems will always have entropy increasing and it will never decrease? How can that be possible in the face of a natural law?
In the natural law, the thing that's unstated, that needs to be stated, is that it's in the absence of any outside forces. And in this case, it's not in the absence of a force or a pressure, as it were, as I like to refer to it as, which is, of course, gravity. So that is how. And the thing is, you say that the vacuum is at 10 to the negative 7 torr. Where exactly is it at 10 to the negative 7 torr?
17 torr, and that's out past the moon.
Okay.
In your model. You know, like I think where the ISS is, which is 255 miles, is like 10 to the negative 7, roughly, according to you guys. It doesn't really matter. Just that's kind of like the maximum that it says that it gets to. The point is that at some point that gas is going to violently fill the available space, seeking equilibrium, and it's not really going to care about any models that anyone comes up with. I do agree, of course, your model's claim is gravity, right? Okay, and so now what we're going to have to figure out is, for one, is that even a thing, right? Because you're making a claim in the face of the second law, right? And you can't replicate this. You can't show me gas pressure locally on the Earth remaining in a container that's open, inside of a vacuum because of gravity or anything like that. So now we need to talk about, like, what, do you agree that gravity, as it is coined, has effectively been falsified? That what people call gravity cannot be true in its current state, and really that there's no evidence for it. It's not like scientifically validated.
So just to go back, blue marble science has shown that in an open container, a gas can exist, a gas as a higher pressure can exist open to a system that is of a lesser pressure. So the second law doesn't state, as it's been formulated by y'all, that it will equilibrize based on a vacuum. The equilibrium occurs when the pressures are different. Blue Marble Science on his channel has shown that no, that you can actually have that. And again, it's based on gravity. That's the reason why the butane stays in the open pipe as opposed to spilling out into the air.
It doesn't remain in there forever, does it? And of course, that's a container. A pipe is a container.
It stayed in there. I think he did the experiment for a day.
I've talked to him about it. He admitted that it ends up leaving the container, and so
eventually,
yeah. And then you're going to get into
in line, and
you're going to get into density there, right? You're going to get into density. What is density? Density is intrinsically electrostatic, molecular and intermolecular attractive forces. Yeah. Oh yeah. And then there's a downward, like what you call weight. You can try to say that gas has weight or whatever, but that is in a container, and the gas ends up leaving. Right. And so you guys are claiming that there's perpetually a pressurized system adjacent to a near perfect vacuum. And you would agree that the necessary antecedent to gas pressure is containment, and that you're claiming that gravity acts as that containment?
I suppose if you put it that way, sure. I do not believe that gas pressure requires a container.
Can you give any example other than begging the question?
The way that gas pressure is defined is the amount of momentum that is conveyed onto a theoretical surface that the particle hits. So you can calculate what the gas pressure. I could calculate what the gas pressure is right here without having a surface. Technically, there is gas pressure right here.
You're begging the question, man. You're begging the question.
Begging the question. Again, I don't use fallacies, so What do you mean by what is wrong?
Well, you use them, you do use them, but you mean I know what you're saying. So I'm saying, like, obviously, bro, we have gas on the earth, right? Like, the question is how. And so if we then point out that there's gas on the air, that we don't have this perceivable container, it's begging the question. And there's evidence that there's a container. I'll go ahead and shut this down real quick. We have equipotential increase of like electrical field on the earth, right? We have equipotential increase 100 volts per meter, right?
I've heard that, yes.
Yeah. Richard Feynman has a lecture on it. Atmospheric electricity breaks it down pretty good. Chapter 9.1. So the requirement to have equipotential increase like that is two Gaussian surfaces, one below, one above, which creates a finite volume so that you can have it equally distributed. And so now we need a physical container or Gaussian surface above us to be parallel to the surface to give us the provably measurable equipotential on the earth. This combined with the fact that all experiments ever will show you that gas pressure requires a container kind of leaves us in this predicament from your side's paradigm to claim that space and time that can't be scientifically verified kind of defy physics, right? Like it's anomalous physics, as I call it.
Okay, so again, gas pressure doesn't require a container. If I have gas sitting right here, and I, if gas is sitting right here, I suddenly put a pressure sensor right here. That pressure sensor is going to give me a value. So are you saying that if I remove the sensor, that gas pressure is no longer there?
No, the reason that it gives you a value is because there's gas pressing in on it from all directions.
Right.
Contrary to what people will want to say, the gas is pushing down on you. Well, no, the gas is pushing, gas pressure of the earth is pushing in all directions. That's why your sensor's picking it up. The question is, what is allowing that gas pressure to be here if it's supposedly surrounded by a vacuum? So when we start...
Well, I'm going back to the whole gas pressure requires a container issue. Is if
yes.
I put a sensor there, what is my container? I'm measuring something.
Whatever's containing the gas pressure on the earth.
No, basically what I'm asking is, right here, what is the container for the gas at this point? If you have a sensor here, it's measuring pressure at this point, and then you take it away, does that mean the gas pressure is no longer there?
No. You're measuring the gas pressure that's on the earth. And the question is, what is allowing us to have gas pressure on the earth? Arbitrarily drawing a circle with your hands doesn't change this. That's begging the question. You're begging the question that you can have gas pressure without a container because we have gas pressure on the earth, but we're trying to figure out, can you have the gas pressure on the earth without the container? The air in your room is the air pressure on the earth, 14.7 psi roughly at the surface, right? So it's begging the question. Obviously, you can't do any experiment to show that you can have gas pressure without a container. I'll concede to you that's kind of like it's almost, it flirts with a bad faith request because in your paradigm you have gravity here and how could you ever do that, blah blah blah. But nevertheless,
pressure is the change of momentum as a function of area. So yes, you can have gas pressure without a container by defining an area in space and looking at the amount of the average momentum of the gas particles as they move through that part of space. That is what gas pressure is defined as.
You said now, defining an area in space.
Sure.
I mean, arbitrarily determining
area.
Like, or volume. Like, it's just you're arbitrarily determining it, but in reality, you have to have some type of something physical, because the gas pressure is literally defined as the energy or force exerted on the walls of a container.
That is not, no, that is, and again, the gas pressure is defined by the change of momentum that would be provided to a surface of some defined area. That surface doesn't physically need to be there for that pressure to exist. It's
okay, but the pressure exists within the confinement of that surface. You're kind of even arguing against your own model at this point, because your model claims that gravity acts as the containment, right? Like, your model does not deny that the second law would necessitate containment. It is just a fact that, you know, that high pressure system will migrate to the low pressure system, and that all spontaneous and naturally occurring systems, entropy will always increase and never decrease. It will spontaneously seek equilibrium, and that the necessary antecedent to gas pressure is containment, but your model claims that gravity acts as that containment, right? And so you pointing out this little area here saying there's pressure is actually even going against your own model and the second law of thermodynamics, and it's begging the question of how we have gas pressure on the Earth. Like,
I still don't know what begging the question means, but what I can tell you is that, again, you have ignored the caveat that I had stated to. Everyone talks about, you know, the two systems that are at separate pressures will equal, if they are allowed to interact with each other, they will equilibrize, I need to come up with a better word. Their temperatures will become the same, their densities will become the same, and so forth and so on. The caveat is, in the absence of outside forces, that is not the case for the Earth. That is not the case for the atmosphere. There is a force acting on that system. There is a force acting on, and by forces, I don't want to quibble. I have stated explicitly several.
I know. I wasn't even gonna.
So
yeah, force that's not a force, but can be thought of like a force, but it's actually the effect of the bending and warping of concepts that can't have physical properties, but we had to because it made the Earth stationary with the ether.
Yeah. So that is true. That second law is true. But again, in the absence of an outside force or pressure, and that is, so when we say that, or when people say that gravity is the container, sure, I guess, I mean, it's what's actually causing the gas to stick on there and stick to the globe. The other thing that people don't discuss is that we are in fact losing atmosphere. If you look at Mars, the reason why Mars looks the way it does now is because at one point it had a fairly robust atmosphere like the Earth, but it lost it. It
How do you know that?
A mass in order to contain that atmosphere, because that atmosphere has a certain temperature, therefore that atmosphere has a certain speed.
So that wait, you're saying that Mars, which I don't know how you would ever know this, but that the air on Mars, it filled the vacuum. Why did it fill the vacuum? Because of the second law of thermodynamics. And you're saying that it didn't have enough mass in proportion to like the velocity or kinetic energy of the gas to stop it from going out there. I understand the concept.
Thermal release. Yeah. I don't know what you mean by filling the volume or filling the vacuum. It would go through the same process the Earth would go through, which is that in its very early stages, it would outgas carbon dioxide, it would outgas nitrogen, oxygen, so forth and so on, and it would form an atmosphere similar to that of the Earth. The question then becomes whether or not there's enough liquid water on the surface of it in order to trap enough of that carbon dioxide, but it would have some kind of robust atmosphere, either Venusian or Earth.
Okay, so I think that we agree, though, you need gravity. You invoke gravity as the replacement for containment, and that would be the first time ever. It'd be anomalous, right, without begging the question that you can have gas pressure without physical containment, and you say gravity does it. So now we need to verify gravity. What is gravity? Do we have any like scientific evidence, like actual experimental evidence of this gravity? Because from my understanding, even if I granted you this version of gravity, which you've never verified, it's just an idea. It's not even a scientific theory, right? It falls apart on the cosmological scale. It's off. Like, it absolutely does. It absolutely does, because 83% of all matter in the universe now needs to be dark matter. That shows that the gravitational relationship doesn't work. Like, let me ask you this.
No, that requires that would indicate that maybe our description of gravity is incorrect. Not that gravity doesn't exist.
No. Yeah. Because gravity means gravitas, which means weight, or how heavy something is. Gravitas means heavy. How heavy something is, weight. I don't dispute that exists. I don't think any flat earther would dispute that exists. We dispute that space and time, two concepts, bend and warp. And in your own paradigm, it doesn't work, right? It doesn't even work. It fell apart. So when you say, no, that would suggest that gravity is wrong. Yes, that's right. It's not true. It's not real. It's nothing. Like, what you call gravity or relativity is not real. It just can't even be real. It's provably wrong, and you guys never even verified it in the first place. So now we're back to the second law problem, right? Like, now you're back in a situation where your model's falsified again.
So you keep saying that we've never supported it, that it's falsified. You're making these very large blanket statements that just are not factual. The fact that dark energy exists does not mean that that relativity has been falsified. What it means is that relativity cannot explain it. There is a significant difference between the two.
You agree relativity basically isn't falsifiable then? Like it's effectively a religion because it's not dark energy as much. They'll say that Einstein calls that his blunder. I'm not trying to be disrespectful when I say religion. It's just a habit. So, but like my point is, you know, Einstein says, oh, it was his greatest blunder, right? And then I guess I remember you kind of alluded to it. Maybe you don't have a particularly popular opinion where everyone's just like, oh, but it relatively does allow for it. And maybe you have a different opinion or whatever. But I don't even push that angle of it because it's the dark matter. You know, like technically it's argued that the cosmological constant or dark energy is allowed for in relativity. Einstein was just wrong thinking that it was a blunder that he originally put it in there. Whatever. Dark matter is the major glaring problem here, right? And what I'm saying is, if you can always just say, oh, it's just incomplete, or it's just something relativity doesn't know about, and there's no way to falsify it. If your theory says this amount of mass gives us this amount of gravity, and then we see this amount of gravity, right, in the sky with galaxies sticking together or whatever, there has to be a really strong pull, whatever you want to call it, but there's not anywhere close to the amount of mass that gravity, the theory of relativity would predict, that would mean your theory's wrong. We see the quote unquote gravity, but we don't see the mass required there, the proportionate mass. But no, that doesn't falsify it. So there's literally no way to falsify it because it can't be physically isolated. Space and time can't be isolated, tested, manipulated. It was never scientifically validated in the first place. It's just an idea. And then when your ideas collapse in on themselves, you guys can then just say, oh, well, no, it's just incomplete. So it is akin to a religion in that way. Like there's nothing I can do to falsify it. Like what can someone do to falsify Genesis? And if I can just start changing Genesis, what can someone do? If I can just start changing Genesis, then what can they do? So do you see how, what is your take on that? Do you see that relativity is effectively unfalsifiable in its current version?
No, it's not. You said that at the beginning, that's why I bowed my head. I was not saying that relativity is falsifiable. I've been on the record online, I've been on the record with my students, that I believe that within their lifetimes, hopefully within mine, the theory of relativity will in fact be replaced in the same way that classical mechanics was replaced with general relativity. If you look at that, if you look at the revolution, the relativistic revolution, as it were, when general relativity essentially replaced classical mechanics as the best explanation that we have, gravity didn't go away. Because the classical mechanics, the idea of gravity in classical mechanics is irreconcilable to the idea of gravity in general relativity. So it truly did supplant it in terms of what we expect or what we think that gravity is. The reason why gravity didn't exist is because, again, as I earlier stated, was that in order for a new theory to come into the fore and actually be used, is that it not only needs to explain the questions that we have now, but it has to answer all of the questions we have already answered.
I can do that effortlessly, bro. I can do that effortlessly. Electromagnetic nature to gravity. Now I'm not limited to proportionate mass. The reason that you guys have a problem is you're limited to proportionate mass, meaning however much mass you're limited to having that much gravity. But if I have two magnets, right, they can be the exact same mass, which is actually volume times density. Mass doesn't exist. It's just a concept. But anyway, if I have the same size magnets, one can be stronger than the other. So now I'm not limited to proportionate mass. I can look out in the sky and be like, okay, that must have a stronger magnetic field, and that has a stronger magnetic field than over there's a weaker magnetic field, even despite the visible mass. I have a way more viable, off the top of my head right there, I have a more viable theory because it's not limited to proportionate mass. You can't do that. You can't do that, though, because you can't have an ether. You can't have electromagnetic causation. You need the bending and warping of space-time, and it's been falsified. Can we be honest with each other and admit relativity has fallen apart, and as of now, it simply isn't working, and we just have some random mathematical band-aid that's kind of keeping it alive right now?
I'm sorry, but I can't agree with that. What I can say is that there, as I've stated before, there are questions that we currently cannot answer with with general relativity, and folks are trying to answer that. One of the problems that we have is getting enough observational evidence in order to have something to test against. So that's the core problem. That's a core difference between falsification and simply not being able to answer something. If GR makes a definitive claim as to, all right, the universe should end at this point, then, and it doesn't, then you can say that it's falsified. And again, as I've already said, I do not believe that general relativity is the end-all be-all of gravity. I believe that through the observations of dark energy and through the observations of the cosmic microwave background, that ultimately a new theory of gravity will have to come to the fore. But so far, nothing has been able to supplant it. You can come up with stuff off the top of your head, fine, but that's not how you replace a theory.
Dude, I can like, first of all, I don't believe in any of this. Okay.
I know.
Right. Like, mind you, I don't believe in any of it. I'm making the point that there is this illusion that this relativistic heliocentric model is the only viable thing and it's eons above other positions. It's not. It's the other way around. It's eons behind a geocentric stationary plane model with a torus field and electromagnetic gravity. This is a fact. You can look up Constantine Mice, the electromagnetic nature of gravity. And I'm sure you've seen the paper. I've had a bunch of people with credentials tell me they've seen the paper. They're going to look at the paper. They'll dismiss the paper, call them a quack or whatever, but they don't ever rebut. I'm not saying you're doing that. I'm saying, but they never rebut it. He actually derives G. He shows an equivalence between Coulomb's law and little g, and he derives big G, and it's within the margin error using the accurate value for vacuum energy and permittivity and permeability. And I don't even believe in that. My point is that it's a viable alternative. Why is your model not invoking it? Well, there's reasons, right? Because you guys have to stay away from any type of substantive background or ether, because now you have a Michelson-Morley problem. It means the Earth is stationary, etc. So this kind of brings us back full circle, where it's like, you brought up a way to falsify relativity. You said something about if it predicts how the universe ends and then it doesn't do that. What? Is that the only way we can falsify relativity?
No, it's not the only way.
Well, obviously it's not based on its actual predictions of this amount of mass, this amount of gravity, because that's been done. It's 83% off in the universe. 83% of the mass in the universe.
It does not. That would say that relativity predicts that dark energy is not possible. It doesn't state that.
Dark matter. Dark matter is 83%.
Oh, all right. Relativity does not state that dark matter is impossible. If GR stated that, stated that all matter must be baryonic, then it would be falsified. But GR does not state that. And let me go back to something. Is if you were asking for a way of falsifying or what have you, and you were invoking electromagnetism, you were saying with Mies, there are a lot of things here, so I apologize if it's stream of consciousness. One of the things I find to be most ironic is that that yourself and Space Audits and others have talked about, this is simply a mathematical construct. There's no physical real reality to it. But then you invoke Mies, which is, as by your admission, a mathematical construct. Now, the reason why Mies has not come to the forefront is, and I'm assuming here, that his theories have not been properly tested. We can get it, whether or not the reasons behind that are another discussion entirely, but it should be noticed that Mies does not invoke ether. Other thing is, and if you want a simple test, and honestly, I will shut up and delete my channel if you can do this.
I wouldn't want
the inclined plane experiment. So I did a video of this back a while. And so what you can do is you take an inclined plane. This is something that Galileo did. You basically have a board on a table, like so, and you put a block on it. And then you time how long it takes to go from stationary to the ground. Through the analysis of forces, you can derive that the acceleration due to a downward force is 9.8 meters per second squared. And you can do that through gravity. By using the law of gravitation, you can pull out that acceleration is 9.8. Therefore, that predicts or that explains that motion involves gravity. Now, if you can do the same thing with Coulomb's law, great. I would love to see it. I honestly would love to see it.
All right, but this is what I'm saying. So when you said we bring up Constantine, and you pronounce it Mies or whatever, Mies, Mies, I don't know, but we don't invoke him as our argument. We're making the point that your paradigm is so dogmatic that you guys don't even actually give proper attention to alternatives, because it is basically like this dogmatic. I don't want to use like volatile words or whatever. So like it's just really dogmatic, okay? And most of the time when I'm saying, well, what's the evidence for gravity? People say what you say. So I'm like, space and time are conceptual abstractions. How do you apply physical properties to it? And then they always end up just losing that part, because, like when we discussed it, you held up a book and said, this is space and time. I said, no, that's a book, right? You describe it with space. You can describe it with how long you held it, but those are concepts, and that's physical properties. It's dismissed right there. We can't even isolate it directly, physically manipulate it. That's what science is. Science is naturally occurring observable phenomena, dependent variable, propose a cause and effect, relationship tests. That's your hypothesis. Then you manipulate the cause to verify it's the effect. That's just basic science. Nothing like that exists for relativity whatsoever. We just mess with quote unquote mass and then assume that space and time are there, even though we never isolated it. So then when I press harder and harder, what is this evidence? It's always something like what you just said. Right, I can use these equations to derive 9.8 meters per second squared. I can use kinematic equations. I can use Coulomb's law. I can use even his big G value from the vacuum energy. That's the type of reason that guy's invoked. It is not to claim his model, just like I don't believe in the neo-Tychonic model. It's to show, no. Just because your math can work doesn't mean it's true. Here's a million other things that can do the same thing with math. Right? So it doesn't count as evidence of anything. Math describes, science explains. Your model, if I granted you relativity, fell apart. It doesn't work. And the geocentric model doesn't need dark matter. It doesn't need dark energy. It's just sitting over here perfectly fine. And it's not even being entertained or discussed. People are acting like there's no way it can be true. That is incorrect. It is more viable than the heliocentric model.
Rob, I'll give you a minute to close this one out, and then we'll go on to claims. So go ahead and finish off this one.
Wow, I have two questions, or two things, and I don't know which one I'm going to go with. I guess I'm going to have to go with, I was going to refute the idea of you saying that a million things can explain the inclined plane experiment. My challenge to you was, do that. Explain it using something other than gravity. But what I want to get to is, and again, we've kind of touched on this, you say that the geocentric model doesn't invoke dark matter, doesn't invoke dark energy. But when I pressed you on what that model is, you claim that that you don't know. So how can you make a claim that the geocentric model does not require dark energy without being able to explicitly tell me what that model is?
I explained it very, very, very concisely and clearly, right? Like no matter what version of geocentric model, it's all the same thing. All of them will have a commonality, which is that the Earth's in the center and not moving. That's what geocentric, all of them, no matter what kind of version it is.
Sorry to interrupt, but neo-Tychonic model does not get rid of dark matter or dark energy.
It absolutely does.
No, it does not.
We don't need dark energy if the Earth's in the center. I don't know why. How does
the Tychonic model explain dark matter within the galaxy?
Okay, let's talk about dark energy first. Because dark matter is going to...
Honestly, I would rather talk about dark matter.
Yeah, well, dark matter is different. Dark matter is going to require you invoke some type of substantive quality and replace gravity. I'm the first to admit that. Either or. So either some type of substantive quality like an ether, right? Or changing gravity and or both, right? So when I just gave you an example of how you can get completely rid of the dark matter problem by not having a theory that's proportionate to mass only. And if it's, for example, magnetism, you can have the same mass, then you have varying strengths with the same mass. Now you can be like, well, look, this galaxy is stronger than that one, even though there's the same amount of visible mass, or there's not enough visible mass here, it just has a stronger field, right? That is a solution, is removing the limit of proportionate mass. You can't do that for many reasons. Dark matter also, you can just have an ether. But this is my point. Dark matter is a number that comes...
You're making claims that you can't support. You
Absolutely.
say they can, you can't say they can, but I have yet to see, like, for example, with Mies, his idea that, yes, okay, he can derive G. But that is just simply deriving G. That has not been applied to the problem of dark matter. I have never seen that explained. And until it is, you cannot make the statement that it can explain dark matter.
How can I explain something that's undefined? What I'm explaining is I don't need dark matter because dark matter is relativity.
The dark matter problem is defined.
Let me explain it. Let me very, very concise. Okay. So the reason the ether got thrown out as a viable framework is because of Michelson-Morley and the assumption that the Earth orbits the sun. If you pull that away, geocentric model doesn't have the Earth orbiting the sun. The ether can pop right back up on the table. Now you have a substantive fluid background medium. You don't have a problem with mass. It can act like a superfluid. It doesn't have to be visible. It's a background medium. Now you have as much material, substantive qualities that you could possibly need. You cannot do that because you can't have an ether because Michelson-Morley is a problem for you if you have an ether. Okay, now that aside, right, I'm saying dark energy is the most glaringly obvious one. It's fundamental because you guys needed accelerative expansion to explain the observations that made it look like the Earth was in the center. No, obviously, the geocentric position.
That is a straw man. That is not what. God, the term. That is not what dark. That is not why dark energy is above.
Yes, it's called the cosmological constant, which is what is supposedly causing the Hubble constant, right? The Hubble constant was built upon Hubble's observations of distant galaxies moving in relation to the what?
Which is independent of the cosmological constant.
No, they're different, but the cosmological constant would be causing the Hubble constant, right?
No.
So dark energy wouldn't cause the expansion.
The reason why I say no is because why did Einstein say it was his greatest blunder? Because Hubble came out with his observations, came up with his Hubble law, the Hubble constant was invoked, and therefore the cosmological constant was no longer necessary. The cosmological constant and the and H naught, lambda naught, and H naught are not intrinsically coupled.
Okay, if the universe is accelerating and expanding, logically speaking, in terms of physics, there has to be a force or some type of energy causing it to do that, right? So, period, you need some type of force or energy that can't be spotted, identified, defined, that's causing the universe to expand. And then there was like the semantical trick of time changing. Well, okay, from our reference frame, it goes 4 to 8 times faster than the speed of light. Okay, and this is what I'm actually entertaining a bunch of fairy tales. Okay, a vacuum of space is a second law of thermodynamics violations. Gravity is just a claim that can't be scientifically and physically verified, independently tested with scientific experimentation. Like I'm just pointing out that the truth is, you guys have theories that can't be truly tested or falsified. And actually a geocentric model is more viable. I understand that you're an intellectual, so you have questions like, okay, well, if that's the case, then how would you explain this and this and this? Fair enough. But that isn't my point. My point is that you guys have a problem that is limited to, that is exclusive to the assumption that the Earth is moving. Those problems aren't there with the Earth not moving.
You are making the claim that a geocentric model can do away with dark matter, do away with dark energy, yet you cannot explicitly state what that model is. That doesn't logically follow.
Bro, I just explained to you, it doesn't matter what version of it is. They all have the Earth in the middle.
And I just explained that the neotychonic model, as far as I read from Anis or whatever that dude is, and Popov, that doesn't, nowhere in there explains why dark matter is no longer an issue. Where the
that's different. That's different.
Solve the missing mass problem.
That's different guys, right? So just to clarify, that's
but that is a single geocentric model. You say all of them do. That one doesn't.
Okay, no. You're conflating dark matter and dark energy. All geocentric models don't have the dark energy problem. All of them, because you don't need accelerative expansion. It was invoked to explain why it looks like we're in the center of the universe. And it's a theory that says everywhere you're at, it's going to look like you're in the center. That is a huge problem.
We'll go past this. Austin, you have a minute to finish this off, close it out, and then we'll give a minute to Rob, and then we'll go on to claims. So 1 minute, no interruptions. Go ahead and finish that off.
Wait, just to clarify what? Because I didn't know.
I thought we've already done that.
Yeah, what does claims mean? Sorry.
Well,
because I know you said
we've been kind of going back and forth on the questions, but I'm leaving it open as long as you guys are having good conversation. The claims would just be now making a claim and backing it with evidence, but we're not there yet. Just close out what you were just talking about. Go ahead and lay out your reasons why.
Okay, yeah. Simply, my position is that the reason that people believe the universe is accelerating and expanding is just like he described with the balloon. It's to explain why it looks like we're in the center, even though we supposedly actually aren't in the center of the universe. But of course, if you have a model that says you are, and you don't need to explain why it's an illusion that it looks like you are. You look like you're in the center because you're in the center. So you don't need accelerative expansion, and you don't need some mystical energy to cause the accelerative expansion. And then, of course, if you could invoke the ether, now you don't have anything called dark matter. Or if you could just change gravity, you don't have anything called dark matter. And if you go back to Michelson Morley showing the Earth is stationary, well, now you have plenty of observations or plenty of potential theories that you could come up with for quote unquote gravity, because you don't need the Earth moving, you don't need relativity to explain away MMX. So that's the dark matter and dark energy situation. Geocentric position is just doesn't have those problems.
Okay, minute, Rob, go ahead.
All right. So the expansionary universe was to explain the redshifts that we see, that there is a correlation between velocity and distance. It is just a consequence of that it appears to us that they're all moving away from us. That is not the core issue. The core issue is, why is it they are not only moving away from us, but they are moving away from us as a linear function of distance. This is not a heliocentric, geocentric problem. And to say so is a mischaracterization of it. Where was I going with that? Again, we continue to state that the geocentric models require or can explain dark energy and dark matter. And I've already pointed out to you, as far as I know, that the neo-Tychonic model from the sources that I've been able to acquire do not claim to state that dark energy or dark mass is not necessary. It doesn't explain why you would see the missing mass problem. The missing mass problem, just to be very clear, is that the amount of mass that we see dynamically is larger than the amount of mass we see optically. So there has to be some reason why for that mass discrepancy, and the neo-Tychonic model does not have an answer for it. Neither does MOND. So, which again is not a geocentric model. But I will close out by stating that, again, until you can articulate what model you're talking about, then simply stating that a geocentric model does not need dark matter or dark energy is not tenable.
Okay.
Until you can explain, you've said that, yeah, there are possibilities of, this, that, what have you, but none of them have been tested. So to make the absolute claim that they do away with it is disingenuous. And that's where I'll leave.
All right. So we can go to claims if you want. So if you think we're already done, we could just continue on the same, but move on to a different topic if you want. But
okay.
The claims is more, you have 2 minutes to make a claim and back it with evidence. So you can say the Earth is a curved ball because we can do this, and the Earth's a flat plane because we can do this, and then the other person gets a minute to refute that. So if you have a claim you want to make, Rob, go ahead.
Okay.
I'm listening. I'm grabbing the charger.
Okay.
Sure.
I'm right here.
Sure.
I'm listening. Go ahead.
Gotcha.
School me, brother. School me.
This is fun. So it's more not really all right. So we see the precession of the equinoxes. Now, to define for those who aren't aware, we define the vernal equinox as the point where the sun is located at the celestial equator. The celestial equator is defined as a declination of 0. More fundamentally, it's defined as the equator. If you took the equator of the Earth and expanded it out to a celestial sphere, where everything is located on that sphere, it is a tool. It is not supposedly. It is not meant to be a 3D accurate. Anyway, getting away from it. So the sun is on the celestial equator as its change in declination is positive. So it is moving continually towards the positive declination. It was defined at the time, when it was strictly defined, it was defined as being, when it was strictly defined, that point was in the constellation of Aries, which is why I am an Aries. However, what we have seen is that now, if you were to find that point, do an observation, go to the, during the autumnal equinox or the vernal equinox, and find out where the sun is in relation to the constellations behind it, you would find that it's actually in the constellation of Pisces. Hipparchus actually found this when he first was cataloging the sky. I'm not entirely certain how he figured this out, but he noted that this occurs. Another consequence of this is because of that precession, or because of that movement of the equinox, the pole star that we see as Polaris now is not always the pole star. And the evidence that I have to support that is that astronomers have used coordinate systems all the way back from the 1950s, a little bit earlier. But when we first codified the right ascension and declinations of a whole bunch of stars, we inserted that this is the 1950 epoch. In 2000, those coordinates had to be changed because of the fact that precession was such an observable quantity, or was such a large effect at this point, that the coordinates in 1950 were now wrong. Now with computers, we can do it on the fly. And so now it is the current epoch whenever you do these things. So to me, that is the best explanation for that, is if the Earth is a sphere and its axis of rotation is precessing around the night sky. So if that isn't the case, I'd like to know how it's done on a flat Earth.
Okay, Austin, go ahead. You can have a minute to come back to that if you want to refute it.
Forgot I got a stopwatch.
All right. Oh, you see the clock on the screen?
No.
No.
Wait, what do you
I'm
mean?
Resetting, bro. I need that 4 seconds.
What picture do you see of me?
I'm only looking at the Zoom, and all I see is an OBS sign.
On Zoom.
Should I be
Yes.
looking
Oh
at
my
the...
goodness! Why didn't you guys tell me that?
I don't know. We've been
Well, look,
toughing
it's
out
just
in the
it's that
trenches
easy.
over
Now
here, bro.
you just should have told me. I just had to turn on my virtual
The
camera.
fact we went so far in the last section was actually your fault.
So now you see the clock.
All right, yeah, I'm actually looking at the YouTube now. I'm going to...
No,
I
I
know
don't.
what-
YouTube's delayed though.
No,
Right, so the
you
clock
should have just
doesn't
been
help.
looking at. I didn't know that my camera wasn't on.
there it is. Yes. Okay, I see it.
Okay, good to know.
See it when you talk. If you spotlight it, we can see it better. But it might mess up your scene. Anyway,
Yeah,
you
I
can
can-
kind of see it.
Yep. All right. So you have a minute to come back at that. I guess about the precession equinoxes.
Okay, yeah. So the motion of the sun on its ecliptic plane throughout the year and its proportionate relationship to the stars or constellations in relation to that is not exclusive to the Earth moving through space. The sun just moves on the ecliptic plane. Actually, you can look at the book Galileo Was Wrong by Robert Sungenis. PhD physicist Robert Sungenis shows the mathematical equivalence. He works it all out. He shows you the exact kinematic equivalence of that, right? That you can explain all of it from a stationary Earth position. Right, this notion that Polaris has moved, I'm not convinced in any way that there's actual substantial evidence other than saying, I think it's going to progress at a certain rate and then therefore this would have happened. There's no actual evidence that Polaris has not always just been right near the center. It's not exactly in the center, but it's right near the center. But anyway, the point is that the way that the equinoxes progress, or the motion of the sun throughout the year on its ecliptic plane, is not exclusive to us flying through a vacuum around it, because our position would be, okay, the sun looks like it's moving because the sun is moving. And so, yeah, I mean, you can break down the kinematic equivalence in many ways.
Okay, Austin, you get to make a claim.
Okay. I got 2 minutes. Yeah.
Yep. When you're ready.
All right. So I'm going to reiterate this. If the Earth is a sphere with a radius value of 3,959 miles, then it's a very specific geometric claim. The horizon has to be a physical, geometric, actual location that blocks things in the distance physically, right? As opposed to what we actually observe, which is that the horizon is apparent, it fluctuates, it's merely an optical convergence point, and it actually moves around. So knowing that if the sphere is in fact real with that size, we can test where this physical horizon is. And it's specifically at 1.225 times the square root of the observer's height in feet, right? Or roughly 7.98 inches per mile squared at easily up to 1,000 miles, right? So, like I said, one of the most precise ways to test this out is not even observations, not getting to the rabbit hole of people just saying refraction, reifying the R value with the category error, fluctuating it with 7/6R, blah, blah, blah. Then using parallel horizontal layers in a flat Earth to do the refraction calculations in the first place, right? We don't need to even deal with any of that because we're shooting microwaves and radio waves line of sight over the surface of the Earth. and microwaves are 300 megahertz to 300 gigahertz. Its beam divergence is only like 1 millimeter up to 300 gigahertz, 1 meter at 300 megahertz. It can definitely not refract around the ball, definitely can't go through the ball, and it definitely isn't going over the ball. So we have a serious problem because 300 gigahertz or 300 megahertz, 300 gigahertz is going to go right through the alleged reified ionosphere, which is a stupid term because gases don't have shapes, right? So we shoot the microwaves, like I said, over 100 megahertz, which is significantly higher frequency than the ionosphere supposedly is, that reflects it back down, which means it would have to penetrate it over 2,500 miles when the curvature of the Earth predicts that it will be physically obstructed with the geometric horizon at 20, 30, 50, maybe 200 miles. Yet we're shooting at 250 miles, right? So that is a physical refutation of the claimed sphere Earth.
Okay, Rob, you got a
Nice.
minute?
Got it on the zero. Very nice.
You had it planned.
All right, so I know one person who may or may be watching this is probably very disappointed with me at this point. But as I said, I am not well versed in the argument of radio waves and the atmosphere. What I am versed in is, yes, there should be a geometric horizon. That there is a geometric horizon. However, we are in an atmosphere. Therefore, that atmosphere must be taken into account. And so from an optical standpoint, I know you talked about radio, but an optical standpoint, I have never seen that done well. No one from the flat earth who has done that experiment has actually accounted for what the globe model would say is the actual distance that you can see. And I think that is analogous to the radio transmissions. As I look into it, I will see whether or not there is something that is being missed in your analysis, and I will get back to you on that.
Okay. Rob, you're another claim. We'll probably just do 3 claims each, and then we'll get into questions from the audience. I think this has been great, though. Go ahead, Rob.
All right. So this is not exactly refuting the idea of a flat stationary plane, but it is talking about the fact that the sun is not local. If you look at there are 2 ways that you can determine the distance of the sun, and this was done the last time this was done around the 60s. You can do what is known as solar parallax, where you look at the position of the sun with respect to the sky on one side of the Earth, and you look at it from the other side of the Earth, and you will see that the position of the sun changes by around 8.8 arc seconds. If you do the math on that, you get that the sun must be at a distance of approximately 149 million kilometers. Then you can do radio transmissions. You can bounce radio off the sun and back again, which again was done, I think, in the 60s, and you get a value that is 146,000 kilometers, or 149 million kilometers. When you actually look at the numbers that I have, and you look at the differences between the two of them, the differences are minute. They are within the error bars of both measurements. So what we have is 2 measurements of the distance to the sun that are independent of one another. One is not dependent on the other. They do not, yes, the parallax does in fact require that you assume a size of the Earth, but radio does not. The radar signal to the sun and back does not have anything to do with the shape of the Earth. Therefore, because they are consistent, that in turn not only shows that the sun is at a far distance, but it also can be used to show that the Earth has a certain radius. Nowadays, we have telemetry from satellites, we have radar to other systems, or to asteroids and so forth, and we can look at the whole solar system, pun intended, globally, and we can arrive an even finer measurement of that distance.
Okay. Austin, you have a minute? When you're ready.
Okay, so effectively, with combining the previous conversation with this one, we can just completely throw out the idea that now we know that the sun can't be 93 million miles away because it requires the radius value to get that value, and we just falsify the radius value. So, of course, that is begging the question, a reification fallacy of your spherical model, assuming the R value, which is in contention, and then using it to then really just assume the relationship with the sun with many different other assumptions anyway. Well, we can talk about the radar, as you pointed out. You have to assume the R value with the first one, but not with the radar. The idea that they saw radar at the sun is absolutely absurd and asinine, in my opinion. They claim to have done this in 1962, and then if you look into it, they actually had to develop an entire new methodology to even supposedly interpret what they were going to do, and most of it's simply theoretical. But this is the funniest part. Here is from, I believe, Brown University. A black body is a body that absorbs all wavelengths of light. Radio waves are, of course, wavelengths of light. No light is reflected, and therefore at a low temperature it appears black. Emission from a black body is temperature dependent, and high temperature a black body will emit a spectrum of photon energies that span the visible range, therefore will appear white. The sun is an example of a high temperature black body, therefore it will absorb all wavelengths of light. No light will be reflected. A black body surface completely absorbs external radiation. The reflectivity of a black body is always 0. Therefore, according to your own model that the sun is a black body, you could not have sent radar, which is light, to reflect back off of it to determine the distance to the sun. So that is incorrect.
I'll give you a minute if you want to respond to that.
All right. Well, I'll be contacting Brown University. Did you say that the sun is what was the exact term? The sun is essentially
it says the sun is an example of a high temperature black body.
Okay. I will be contacting Brown University because that's just simply wrong. The sun is not a black body, and that can be seen through the idea of line blanketing. Are you familiar with line blanketing is the term that, based on the atomic structure of the composition of the atmosphere, the envelope of the sun, some of that light is going to be impeded from getting out. And that light has to go somewhere. So it, instead of going out in the ultraviolet or in the blue part of the spectrum, it actually gets shunted out to the red. Therefore, it is not a black body. It does not act like a strict black body. It can be approximated as one, but it is not, in fact, a black body.
Okay. Austin, you could do your second claim. Okay.
Oh, my next point or whatever?
Yeah, your claim, and yeah, you just refuted that. Yeah.
Okay.
His was the distance to the sun. That was the second one. So you're doing your second one.
Okay.
Oops. I'll start your clock when you start.
Okay. So, of course, the claim that the Earth is a tilted, wobbling, spinning, revolving ball is a positive claim. I was actually being generous. I normally go much more in depth with the description. But anyway, so yeah, the idea is that it's spinning 1,037 miles per hour east of the equator. And the claimed evidence of this, for example, is a gyroscope. And if you look at Michelson-Morley, which is a very precise interferometry measurement, they did not measure the orbit of the Earth as they suspected with the friendship. Then they did Michelson-Gale-Pearson, and it did match the sidereal rotation prediction within 98% accuracy. That's called the Sagnac effect. The Sagnac effect still to this day cannot even be explained by relativity. It's not even agreed on how to explain it. There's like 12 different claimed ways to try to work out the math of the Sagnac effect. No one can explain it within relativity because it directly contradicts it. Anyway, the problem is that we've now replicated these, as I mentioned earlier, and to be fair to him, he hasn't seen them apparently, but we replicated interferometry measurements, and at different altitudes, but at the same latitude, we get different friendships. And that this actually changes with the equinoxes. It has maximum and minimum friendships corresponding to the friendships, and it changes with altitude. So anyway, the idea that this friendship would supposedly show the spin of the Earth is just a conflation between correlation and causation anyway. But it's even worse because when we look at these measurements, it changes with altitude, and it shows that C is actually variant and has a preferred direction. It changes with the equinoxes and with the time of day. That directly refutes the claim that the Earth is rotating underneath this interferometer, causing the friend shift, right? Which means, since the data directly corroborates the sidereal rotation observed, the only viable option is that there is no orbit, that the Earth is not moving at all, rather that the stars are moving around the Earth, and we're able to detect it, and detect it even more so as we get higher. So those interferometry measurements refute the globe model.
Okay, Rob. Minute when you're ready.
Yeah, I'm ready. As you stated, I haven't seen these observations, so I can't really speak on them. So I will beg forgiveness in going off on a slight tangent. I've done optical interferometry where I have used multiple telescopes in order to simulate the size of a larger telescope in order to get finer resolution on a star. in doing so, what we have to look at is essentially the arms of the interferometer in the plane of the observations. Basically, we have, from the perspective of the star, the baselines of our interferometer are not as large as they are if looking directly down upon it. You have to actually, there is a projection effect. Now, funny thing is, for things like Michelson-Morley, those are very, very small interferometers. So the interferometers that I'm talking about, which are 300, the one I used was 361 meters in longest extent and one arm, the curvature of the Earth has to be taken into account. And so you have to use spherical coordinates. And I'm out of time. So basically, since we need to know what that baseline is precisely, we have to use curvature of the Earth and so forth. Ball. Anyway, sorry.
Okay, you can go to your next claim or last claim, whatever you want to call it, and then we'll do a conclusion. Go ahead, Rob.
For me?
Yep, when you're ready.
All right. So this is tied to the observations of Romer, who looked at the period of Io. He was looking at when Io appeared out from behind and going into in Jupiter. What he realized was that that timing was different depending on the time of year. And what he inferred from that was that the speed of light had to have a finite value. Now, not going to really get into that because Romer's value was off by a good fraction, but it illustrates a point, which is that because of the motion of the Earth around the sun, observations of periodicity need to account for the motion of the Earth. Because if you do not, then you are not accurately determining what that motion is relative to something else. You have two binary stars going around, and you want to know what their period is so that you can determine the masses of these two stars. You're going to be able to need to do that regardless of when you observe this thing. And so what is traditionally done is that we use what is known as a barycentric correction. We account for the fact that the Earth is spinning, we account for the fact that the Earth is revolving, and we account for the fact that the sun is moving through the galaxy. Only when each observer does that do we actually have consistency in the periods, or more specifically, the ephemerides of these periodic elements. And we can do that now. We know those values now, such that we can determine the precision of radial velocity measurements down to the centimeter per second level.
Okay, Austin, minute when you're ready.
Let me reset.
The clock's on screen.
Okay, so whenever you say that you're accounting for the spin of the Earth and the orbit of the Earth to make your observations, what you're saying is you're accounting for the sidereal rate of rotation, and you're accounting for the equinox precession or in the annual precessions observed. You attribute those observations to the Earth moving. Sure, you have to account for that rate or precession, but that doesn't mean that it proves that the Earth is spinning or orbiting. Again, we've already laid out there's a kinematic and even a dynamic equivalence. The kinematic equivalence is all that matters here. We're talking about making observations. So you determine your barycenter by assuming that the cause of the sidereal rotation or rate of rotation and the actual precession, the annual precession of what we observe in the skies because the Earth is spinning and revolving. You can obviously just denote that those things are moving, the Earth is not, still have the same rate or differential that you're using to determine your ratio of all subsequent observations. So you don't have to actually have that the Earth spins and revolves. It's a kinematic equivalence with observations.
Okay, you want to do your last claim, Austin? 2 minutes when you're ready.
Sure.
And then we'll go to 2-minute conclusions after this, and then we'll take the questions from the super chats.
All right, this one's going to be tough to fit in, but because we covered quite a bit, we covered well, I'll cover that in conclusion. So one thing I will bring up is, so there was it's called the Michelson-Morley experiment. Some people in the community get triggered. I call it that. Oh, it's not a scientific experiment. Okay, fair enough. It's an empirical measurement with interferometry with immense precision. And it showed that there was a fringe shift, and the globe model predicted that there would be a specific amount of fringe shift with a 30 kilometer per second orbit around the sun at the time. Since then, relativity has been proposed and then evolved into general relativity. And it basically says that you don't expect to see a fringe shift. And one of the main reasons it says this is because it says that there is like translational motion and that the linear motion of the Earth will not be detected because you're going in a straight line just through a geodesic path, the bending and warping of space-time. So you're not going to be able to use interferometry to detect that motion. Now, we did see a fringe shift, okay? And that shouldn't be there. And what Einstein said is it must be instrumental error, and no one to this day in 2023 has come up with any other explanation. The fact that we see a fringe shift immediately refutes the claim that the Earth moves around the sun, unless you just say it's instrumental error. In fact, to quote Einstein, he said, if Dayton Miller's results, which he replicated at hundreds of thousands of times, accounting for all instrumental errors that could be proposed, if his results are correct, that relativity collapses like a house of cards. 5 years later, in a letter to Lorentz, he then says that experiment reigns supreme. If Dayton Miller's experimental results are verified, that relativity must be done away with. Well, it's been verified hundreds of thousands of times by Dayton Miller himself, and it's been verified as recent as 2020. There is a fringe shift observed, and that refutes the claim the Earth moves around the sun. Further, actually, Wang in 2004 showed that you can detect linear velocity with an interferometer. Therefore, refuting the claim you wouldn't be able to detect the translational linear velocity, which goes back to MMX, meaning we would have had to detect the full 30 kilometer per second fringe shift, which we didn't because linear velocity is detectable. And worse than that, or in addition to that, the fringe shift is consistently been replicated, which cannot exist and needs to be instrumental error for your paradigm. Therefore, orbital claim debunked.
Okay, a minute, Rob, if you want to come back to that. Oh, you're muted. You're muted, Rob.
Oh yeah, I was eating.
No
no one wants to hear that. So you claim Miller, you claim Wang. Yes, they found fringe shifts. From my understanding, they didn't find the same fringe shifts, so that seems to be a problem. The other thing is you claim that it's been replicated hundreds of millions of times. It hasn't. Miller has done it a set amount of times. I doubt it's been millions. But really only him and a handful of other people have done that experiment and actually found fringe shifts, and they aren't consistent with one another, which leads me to believe that those fringe shifts are due to something other than rotation. Michelson-Morley did, you claim that Michelson-Morley found a fringe shift. Technically, I suppose that's true, but in reality, no, they didn't, because it is the fringe shifts that they detected were not statistically significant within the error of their instrument. What they did not detect was, by any stretch of the imagination, is the fringe shift that would be predicted to occur if it were moving relative to an ether.
Okay. Any comment on that, Austin? Or you good?
Well, yeah, I mean, yeah, it's just not true, and he did replicate it himself over hundreds of thousands of times, and it has been replicated now. And Wang doesn't have a different result. That's linear velocity. It's a totally different measurement. All of them have been replicated within like a very small precision of each other. And Dayton Miller, to give you an idea of this error margin talking point, it says here, as before, the interferometer has a sensitivity represented by a light path of 214 feet, or about 130 million wavelengths of light. The numerical results are reliable to the 100th part of a single wavelength of light, corresponding to 1/2 of a kilometer per second of relative motion of the Earth in the ether. And of course, it's supposedly going to be 30 kilometers per second. And his measurements consistently showed 10, which means that it would be 9.5 to 10.5 at the most, because it has immense precision. Since then, we have even better precision that's been done with millimetric precision with radio waves, etc. And the people that supposedly tested and don't get it, they do everything Dayton said not to do. They change the arm lengths, go into a basement, change the medium, etc. to cook the book. So it's just a refutation of the orbit. There's really no way around it.
All right, excellent. I'm going to let you guys think about your conclusions. And before we get there, I just wanted to say a big thank you to Rob. Thank you for coming on. I thought it was a great conversation. I wish that people pay attention to this and notice what a pleasant conversation can be, what a pleasant debate can be. And I really trust Rob that he's going to go and look into these things that he said he's going to look into. So if we did it again, maybe we could, stick to those topics or things that, you guys disagree with, and see if we can ever get somewhere where we start agreeing on some of these things. So thank you guys very much. I'm going to check right now the super chats, and we'll ask you guys some questions. Oh no, I'm going to check those during your conclusions. So Rob, you go first. You got 2 minutes when you start. Whenever you start, I'll start the clock.
2 minutes. Okay. I am the first to admit that there are open questions in astronomy. I am definitely the first to admit that there are open questions in the field of cosmology, to the point that I suspect that we may have become too speculative in our explanations for things such as dark matter and dark energy, and that we are not actually allowing for equal time, essentially, to explore other options. However, at this moment in time, the best explanation for the observations that we do have, that we can explain, is GR, and that includes the fact that the universe expanded from some point, some beginning, and has evolved to the point that the Earth is in fact a globe with a moon revolving around it, and the Earth is revolving around the sun as we move forward. If one is going to claim that the geocentric model is a better explanation for the questions that we have that are outstanding, and like I said, the questions that are happening before, then that model needs to be explicitly stated. Experiments have to be done using that explicit explanation. And then those results need to be brought to the forefront so that the scientific community can honestly judge them and evaluate them. Simply claiming that a geocentric model does not need a dark matter, does not need dark energy, without providing any kind of context, certainly without providing any kind of mathematical structure to it, is insufficient. It is not. That is simply a claim without not even evidence. It's a claim without even specificity. So until you can make a claim that a geocentric model actually has specificity and has evidence for it, conclusive evidence for it, I have to reject it.
Okay, Austin, 2 minutes when you start. I will start the clock.
Boom. All right, yeah. So, like I said, first of all, I probably could formulate a model, and it would take some time. And you had probably 4 million people helping you do it over the course of hundreds of years and billions of dollars and all kinds of universities or whatever. But I could give you a dielectric plane through a torus field with a vortex within a superfluid-like background medium, with everything being magnetic and not proportionate to mass. And all of a sudden, I can explain way more than you can. And I don't need accelerative expansion or dark energy. The point remains the same. It doesn't matter what type of geocentric model it is. We don't need the universe to be accelerating and expanding in all directions to create the illusion that the Earth is in the center, because the Earth just is in the center. We also don't need dark matter because we're not restricted to relativity, which is why you have the dark matter problem, because you have to hold on to relativity, just like he said in his closing. It's the best they can come up with to date, which means that there must be dark matter. Relativity is true, dark matter must exist. Well, the reason you need relativity is, again, because of Michelson-Morley, to explain away the reason you weren't able to detect the orbital velocity of the Earth that is assumed. And to loop back on that, yes, there was in fact a fringe shift. It's been replicated. It's been replicated with more precision. It's been replicated today. The only time they can even claim to get closer to zero is they have to go to a basement, because Dayton found out the higher you get and the closer you get to the sky, the more you detect the motion. So what do? They go underground. You have to have the same length arms. What do? They change the length of the arms. So it shows a preferred direction of light, which falsifies relativity. It shows that relativity that's the speed of light is actually variant. It changes. That completely falsifies relativity and the globe, therefore, because again, Michelson-Morley requires relativity as the explanation. So Michelson-Morley is just a very specific, precise measurement that refutes it. So we covered that. We covered the second law of thermodynamics violation, that is the vacuum of space. We covered the radio wave propagation being over 100 megahertz, completely physically falsifying the claimed geometric horizon of the globe. So we falsified the motion, we falsified the orbit, we falsified the curvature, we falsified gravity, and we showed that the geocentric model is more viable in many ways. So then again, that just justifies our position that the Earth is a geocentric stationary plane, and the tilted wobbling spinning cartoon ball just antithetical to evidence and common sense, and we reject it as such.
Excellent job, guys. I was just going to say to the Globers out there, see, we want to have these conversations. I was just saying, nobody called anybody stupid, but then at the end, Austin put a cartoon ball in there. So that way to go, Austin.
Oh, sorry. It's a habit. It's a habit.
He didn't.
No, I get it. That didn't even, if
Okay,
I were
good.
to quibble about anything, it was the whole religion thing, but
whatever. I know, because that's what got us into it last time, and that's also another habit.
Yeah.
It is kind of a religion, though. What did you think about my point that it's like Genesis? Like if you talk about inflation, like oh well, inflation. How can I refute or falsify that? Like you just made up a new creation story that I can't even test. You know?
Well, the idea is, and this is the problem that, well, not all right. Let me first state that the reason why inflation was put into the model was because of the fact that there are structural anomalies, or there's structure rather in the CMB. So if there was no inflation, what we would expect is that the CMB would be essentially uniform everywhere in the universe, but there are these small changes in temperature. So if you wanted to refute inflation, what you would need to do is you would need to come up with a model, a mathematical model, or at least one that is descriptive in that way, that given the evidence that we have for the map itself and other boundary conditions, that you can explain why those asymmetries are there without having to invoke inflation.
Okay. Yeah, I wasn't trying. I mean, yeah, it's all good.
Yeah.
I mean, inflation also helps you explain why the universe is so flat and you don't have positive or negative curvature, which was a major fine tuning problem for your paradigm. And a lot of people in your paradigm hate the idea of God, right? So fine tuner must be avoided. But
all right.
I'm sorry, not you, not you.
No, I was expecting you to say that they hate the idea of inflation.
No, I meant fine tuning. It was a fine tuning problem. The flatness problem was a fine tuning problem. That's all I'm saying.
Well, and also, I don't think they hate the idea of God. Most, yes, there are some.
They consider it a cop out. Is that a better way to say it? Like they consider a God a cop out. They try to avoid the cop out.
So the scientific method, as practiced today, cannot or does not invoke any kind of divine intervention. Essentially, that is the realm of metaphysics. And physics has nothing to say about it. Metaphysics,
except for space and time.
Space and time is not metaphysics. It is.
That's what you say. All right, Jared. I'm sorry I started it back up.
Yeah,
I always love talking to you. We'll have to talk again in the future.
Yeah, you guys gotta do it again. It's a good conversation. I think everybody enjoys. I could listen to that every day. I mean, compared to other conversations, which I can't listen to ever again. So we're gonna go through some of the super chats. If you guys want to get them in right now. And then we'll go to Rockfin after. So we've got Matthew DeGrorio. Thank you very much. He says, keep telling the truth. We'll find out everything. I like it. Thank you. Swamp Boy 34 says, please address the pancake floating in space idea before he starts. I'm pretty sure he knows that.
Yeah, he's pretty familiar with some of the conversations. We obviously don't think that. Hey, Rob, real fast, like really fast, like when he's talking about, like, tell him about how there's a strawman version of flat Earth. Would you agree that you've kind of that looking into this community has caused you to kind of look into certain things that have gone kind of swept under the rug in a way, and that you've learned, like, for example, Dayton Miller's test and subsequent replications and stuff, that you've like learned quite a bit from the information that comes out of this flat Earth community? Oh yeah.
So I will certainly explain that. Certainly say that one of the things that, and I made a little video about it, is the benefits that I've gotten from looking into this community and hearing the questions that people have asked, and I have to say, notably Rachel, is that, they've forced me to really look at the content, look at the physics, and not just, throw something out of my ass. And so because of that, I've been prompted to go back and review cosmology to a far larger extent than I probably would have done before, and I've looked at, nothing seems to be coming to mind at this point, but, I looked at MEES, I looked in the neo-Tychonic model, which I had no idea what the hell that was about. And so, yeah, I've looked into, it definitely has expanded my horizons in that sense. So.
Yeah, I'm just trying to dispel the illusion that flat Earth's a bunch of like crackpots that live in their mom's basement and don't know anything.
Some are.
I do think that there is a little bit, particularly among people who are not in this community. I don't know of any debunker who honestly thinks that a flat earther believes that it is a pancake or pizza in space. It seems to me that the idea.
Just bad faith, then.
Well, and I could be wrong about this, but I think it's a fairly consistent view that, from a flat Earth perspective, that space ain't a thing.
Outer space as has been defined, yeah.
Yeah, so the idea that it's floating through space, that's, again, not true because you guys don't believe in space. So it's not possible.
Okay. We've got, thank you very much, Justin Johnson, for another 5 memberships. Appreciate that. Matthew again says, seek and you will find. I agree with that. Towns says, typical messy room for a globetard. Glasses can't even see. That's really nice of you, Towns.
Hey, man, be nice.
I know, come on. That's not very messy either. I mean, good thing you can't see over that side of my computer.
What it usually
I clean
is,
this
yeah.
up before I do the show. LJ, $1.99 says, using 1960 tech in 2023 to prove globe religion.
Oh yeah, 1962 radar to the sun. Yeah.
Gotcha.
No, I mentioned that it was we have much more modern views. That was the last time that 2 independent measures that I'm aware of were used and were correlated to each other or were the same. So
okay, and
You didn't shoot radar at the sun, Rob, bro. Let it go, brother. I'm just kidding. Let's move on. Let's move on.
I do want to see that. These are always the things I want to see. Somebody show me. I want to go somewhere and then show me that they can do that rather than just hear about it. We've got another Justin Johnson 5 memberships. Thank you. Great contributor to this channel. And we've got Kryptonian says, absolutely a great debate. Absolutely a great debate. All right. Thank you. Twice. We've got Salvatore Papadilio says, our boy Whitsitt is wicked smart. Awesome. Thank you.
Thank you, bro.
Oh, that was me. And then we've got auditnasa.com from 10mmj. Yes, go to auditnasa.com. We've got Harmon Walker says, does Austin dye his beard? It looks perfect. Thanks, Harmon. Way to pay attention to
That would be really weird.
Dyes it red. Rob, you have to believe we are moving 88 times faster than the speed of sound, yet the constellations are always like a perfect clock. That's from Justin Johnson. Any comment on that?
That speed of sound is irrelevant because speed of sound requires a medium, which there isn't one. But that's basically just a big number. But you to invoke another big number, those stars are so far away that our motion is essentially imperceptible. Like you wouldn't be able to see that motion. Very much like if I drove by the Rockies hundreds of miles away, I can see them, but they don't appear to be moving relative to my car.
Dude, if you can see the Rockies from hundreds of miles away, welcome to Flat Earth, brother.
Well, I fell right into that one. So.
And then we've got Question the Answers is a member for 3 months, and he said, excellent, gentlemen, thank you. All right, that's awesome. You guys are great. We're going to go over to Rockfin and see who's over there, and then we'll call it a debate. I think I'm going to stay on with Austin. I did say I'll give away a VIP pass to the summit, which starts tomorrow, so we'll wait till after the show. I'll do that. I'm going to basically ask questions from the debates to see if anybody was actually listening to the whole thing. All right, let's go to Rockfin. What's going on here? All right, there we go. And we got Eric, $5. Thank you very much. We got Rasco Hearn, $10, says, Whitsitt is killing it. So sad that these intellectuals cannot get past their models or equations. How do they explain ancients predicting all the celestial phenomenon without the use of computers or convoluted math? Mega kudos for staying so calm and collected. Thanks to Jaron, the supreme moderator. Hey, thank you. I guess I don't know if you want to answer that.
I would very much ask what he means by all. What they could predict was those things that are in fact cyclic. And they did so by just simply observing when they happened over a very long period of time. They didn't predict them. They just simply observed what was going on. That is by far not all astrophysical events.
Yeah, but Antikythera mechanism, man. We still can't replicate it or fully understand it even with supercomputers. Shout out to the documentary Mechanical Realm. Have you heard about that, Jaron?
Yeah, it's good. Saw it.
I haven't seen it, but I heard it's really good. Yeah.
One of my colleagues is obsessed with that fucking thing. So,
So, what would you say to people that say that eclipses are predicted only because of the globe? So obviously those are cyclic, right? That's why they were able to be predicted before. So
the Soros cycle predicts the times of eclipses. It basically predicts when eclipses are going to happen within an 18.3 year period. Mm-hmm. For the moon, that's okay because the entirety of the people who can see the moon see that eclipse. The problem comes with solar eclipses. The Soros cycle has nothing to say about the location. It certainly doesn't have anything to say about the location to the precision that we now know these solar eclipses to occur.
We can map that all out on a plane, bro. If you wanna see it, holla at your boy. I'll give it to you. I'll give you the little model, predict all the eclipses locations.
Flat Earth.
Okay.
Flat Earth
Yeah,
Eric says,
if you can show me solar paths, totality paths based on a flat model, yeah, I would love to see that.
Yeah.
Flat Earth Eric says, thank you all for this great discussion. The audience will be the winner. I agree with that. I think everybody learned something tonight. Nuba, thank you very much. You put 2 question marks. Hey, I don't know if you noticed, but my Jeranism.fun is not working. I was going to use that CoinToss website today, and it is not, not completing. Flat Earth Eric says, many thanks to Dr. Parks for saving me from looking at Craig. All right, best comment of the night.
Let's be kind to Craig. He
Right,
apparently has a
little issue
that's dealing with. So yeah.
Okay, Parks and Whitsitt both. What is the purpose of relying on mathematics to confirm the model? Who wants to go first on that one?
Math is just descriptive. Science is explanatory. You can describe anything with math. It doesn't mean that it is reality. So I think math is very valuable, and it helps us replicate things, and maybe even sometimes helps us kind of predict things, if you want to say that. But it isn't reality. It's just descriptive. It doesn't help us actually have explanatory power, which is what science does. Science explains. So that's kind of my take on that whole thing.
My take is that science can explain, but more specifically, science predicts. And that is why you need a mathematical formulation, is that through mathematics, you can predict future events based on physical principles that you use to construct that mathematics. Mathematics cannot explain anything. This idea that you can manipulate the equation to explain anything that you want, I suppose that's true, but you will get called out on it by the community. One of the things that we frequently critique other people's models for is if it has too many variables. If it has too many variables, then yeah, you can explain. I actually had a colleague who explained the light curve of a particular phenomenon using a model, literally by having an illustration of Santa Claus go across the star, gave the exact same light curve, but that was because it had a ridiculous numbers of degrees of freedom. That is called out in physics, and when we talk about things like the law of gravitation, things of that nature, they do not have that baked into it. So
yeah, they just have dark matter. That's a big deal, bro. Let's be real.
It is a big deal, but I don't. Again, I will very much push back that geocentric model has explained it in any way.
Oh yeah. Well, again, you can have an ether, and you need a substantive additional material characteristic. We have that. Hey, there's another super chat. Just so you know, I don't want you to miss it.
Thank you. I'll go back to that. We've got T. Baggins says, great debate and conversation by both. And we've got Flat Earth Eric says, Dr. Parks, how do you confirm parallax is accurate?
So you can confirm it one of 2 ways. The way that it was initially confirmed was through radar finding. So we would look at an asteroid, for example, and use trigonometric parallax to determine a distance to it. And then we would basically shoot a laser or radar pulse at it, and determine its distance. And so you have 2 independent ways of determining its distance. If they agree with each other, then you have confidence that trigonometric parallax is reliable. You can also do the same thing with, at the far end, with Cepheid variables.
Which one? Not radar.
No. So you can use Cepheid variables to verify that trigonometric parallax also works.
Oh, gotcha. Okay, gotcha. Yeah. And let me go back to these. Thank you, everybody. Rockfin, appreciate that. We're going to go back to YouTube here. We've got, where are we at? John Marco says, Saucy a vortex from above level. Oh, boy. I don't know if that's, am I just not reading that right? Saucy a vortex from above level UNCL, Uncle Addis, right? 88? I have no idea. Sorry, guys. I don't know. 279, but I can't figure that one out. Jazz Jacket, thank you. $50 or 50 Canadian, whatever that is. Fantastic conversation, both of you. Thank you for being respectful to both presenters. What is the first experiment you put together, irrespective of cost, to further demonstrate your position? But what is the first experiment you would put together? Okay, got it. Whoever wants to go there first can go. Let's say there's no money involved. You can do anything you want tomorrow, Rob. What would you test? or what would you put together to demonstrate your position?
Oh, if money was not an issue,
Yeah, money's not.
Yeah.
what would be my first? Well, I would shoot a rocket into space, and with a camera, take a picture of the Earth. That would be the most
GoPro?
direct way. GoPro or whatever. Well, if cost is not an issue, I would go for like a ZWO or an Apogee camera. Yeah, if cost was an issue, I would just put myself in a rocket, launch myself into space with a camera, turn the camera at the Earth. It's a big sphere, and then turn the camera at myself, give a peace sign, and there you go.
Very cool.
I'll go with you, bro.
All right.
There you go. Or just ask an astronaut to do it one time. Be good too.
Oh yeah, we can trust them. Maybe you won't go.
We've got Mag.
Wait, let me answer.
Oh yeah, sorry,
So,
I forgot about you. No,
I currently have 3 tests, okay, and I'm gonna end with the one that would answer this question best. But the first one is take a gyroscope, multiple gyroscopes. Shout out to Dave.
Shout out to Dave. Flat Earth, Sun,
taking
Moon,
multiple-
Zodiac Clock app, and other things.
Topographical plane, magnetic declination, a gyro compass app. So we'll take multiple gyros on a plane. We'll take a really long flight. We'll charter it going south, and that gyroscope should consistently tilt over and then should flip. And if we go that far south and it does not flip, the Earth cannot be a sphere. So that's one definitive test. Another one that I want to do, and we're already kind of organizing it, is send radio transmissions of all frequencies from Tampa over to Louisiana, so directly over the body of water, so there's no topographical obstruction. Do the math so that the person receiving the signal in Louisiana and or Tampa, vice versa, is right in the skip zone or dead zone that the globe model predicts, and by a couple hundred miles in each direction, so that supposedly this radio wave should be going to space, bouncing off the ionosphere, creating a skip zone with the person right in the middle of the skip zone. If they receive the signal consistently, that refutes the globe physically, even though we've already done it with what I presented earlier. And then the third one, which we're actually working on with potentially a nice documentary that can help with the funding, is a modern replication of Michelson Morley and Dayton Miller tests, but with immense precision, top of the line equipment, right? Maybe we can work with universities and go to different altitudes and maybe even show the correlation. So basically replicate that with 4K documentation, changing altitudes, showing that there is a preferred direction, that there's a variant, quote unquote, propagation rate or speed of light, quote unquote, and then that it changes, which would refute that the Earth is a spinning sphere. And that one would maybe be a little more expensive. So if costs weren't an option, I would probably do that. So there are 3 tests that I consider to be definitive, and yeah, hopefully we can make them happen.
Awesome. All right, and next we've got DITRH. Dearth says, Professor, if I was driving past the Rockies hundreds of miles away, then they would hardly even move. Austin, welcome to Flat Earth. And then cue the...
Oh, you actually had it ready.
Thank you.
Nice.
You got West Flat Earth says, welcome to Flat Earth, Professor. Snacks in the back. I didn't know anybody brought snacks. That's awesome.
Shirts on the way. Smoke them if you got them.
John Marco says...
Will there be punch and pie?
What's this again?
Because more people will come if there's punch and pie.
That is true. That is true. Swastika is the 2D vortices from above HH.
Okay. He's saying that the swastika is 2 vortices from up above.
Okay.
Yeah, well, I mean, you know, the dipper turning around in the seasons kind of is that. The dark sun symbol being more of it, which...
Well, the
could fit
swastika
in.
was at one time a positive thing. I mean, it was a symbol of the sky, right?
It's a symbol of
Peace.
protection.
Oh, protection. Okay.
And it's about the seasons.
All right, and that is it. And then let's celebrate their 3rd super on a live stream. Happy 3rd super to John Marco. Hey, Rob, thank you very much for coming. I appreciate it. I'm going to stay on, but you are free to go if you want to say any goodbyes. By the way, in the description, guys, is a link to his channel and his Patreon and other ways of getting in contact with him. I think his email address is in there as well. Anything you want to say?
And what I would say is that I would love to have these kind of conversations with other flat earthers, not strictly debates, but I am very much interested in why you hold to these beliefs, because particularly since I realize that there is a lot of backlash, there's a lot of, shall we say, persecution for holding these beliefs. So I'm very much interested in why this draws to you and why you feel that the scientific community is either wrong or misleading. So if you'd like to have that conversation with me, or if you would just like to have a conversation like I just did with Austin, please feel free to contact me. Check out my videos if you're interested in, astronomy content, or at least all that sort of thing. And the last thing I will say is, that observation that you were talking about, I've lived in Tampa, I've lived in Baton Rouge. Those are the two worst places I have ever lived in my life. So it's, of all the places that I've lived, the fact that you want to do it in the two places that I hate the most, just kind of.
That's funny. I just live like outside of Tampa, and it's just an area that I could get to, and then Louisiana is like the right distance away. But
I lived in Tampa for 6 years. So.
Oh wow! I want to shout you out though, because you took this debate like last minute.
He did do that.
So that was super clutch, and we always have respectful conversation, even though we disagree on probably a list of things that we couldn't even count. So shout out to you for always being respectful and for jumping on last minute, having a respectful conversation, brother.
Yeah, I really appreciate it. And one thing, we always hear from everybody, a lot of people think we're lying, Rob. They think that we don't believe what we say, which is one of the strangest positions that I've seen from global believers, to just immediately assume that we can't possibly be serious and we're all liars and we're all doing this for money, as if this is some get rich quick scheme to get made fun of every day. But I don't think you think that, do you?
No. Well, I have my concerns about certain people, but I haven't really looked into it. I certainly don't think you are. I don't think Austin is. I do believe that you are sincere about your beliefs. I've heard a lot of things about Dave Weiss. I haven't looked into him myself. I have some, like I said, just to be upfront, Nathan Oakley, I have concerns about his honesty, or integrity, as it were. So, but outside of that, I can't really name any of them that I would, off the top of my head, that I would question their sincerity. For the most part.
Dave definitely believes the earth is flat.
More than anybody.
Oh, all right, okay.
I can't even talk to that man without it being about flat earth, bro.
Just so you may be already aware, but there are accusations that
because he has an app. Just the fact that he has an app and people pay for it, then he must actually be a Masonic shill or something. But anyway,
because he has an app. All right. Well, thanks, Rob. We really appreciate it.
All right. You guys have fun.
Okay.
Peace out.
Bro. Peace. All right. Excellent job. That was fun. Let me fix the screens because everything's going to be screwed up now for a second. I'll fix it. I'm going to put myself back in and show self view. All right. There we go. You just have to deal with that. Oh, I can make myself larger, actually. All right. So, Austin, I got a couple questions we can ask people. I don't know if you can think of some. I have two. I'll type them into the Zoom and you tell me if you think these are good. So we'll give away a VIP pass. Why don't you tell them what's going on tomorrow, Austin, and I will get these questions ready. I think what works well is if I ask like 4 questions and then the first person who answers in the chat. And guys, I know if you're on Rockfin, well, I guess Austin can watch Rockfin and I can watch YouTube. And we'll just see who, yeah, let's do that. So then you can answer either at Rockfin or YouTube. And
I really need to use the bathroom.
Go. I can.
You want me to go ahead and talk about something real quick, or you want me to just wait? Come back.
Either way you want to do it. I'll play the trailer real quick. You can go ahead and go to the bathroom. You'll be fine.
Okay.
Okay, we're gonna play this and we'll be back. Let's see here. And that way. All right. And where is it? Right here somewhere. All right, there we go. We'll be back in 30 seconds. All right, so that is starting tomorrow at, I believe, doors open 3 p.m. Pacific, and we go through till late in the evening. I think the VIP Q&A session is from 9 to about 10:30 or 11 p.m. Pacific time, and then we go Saturday pretty much all day. We start early, 9 a.m., I believe. 8 a.m. doors open, 9 a.m. till 7 in the evening. We'll finish comedy at 7. and then we'll take a little dinner break, and we come back at 7:30 for the VIP after party. And that's fun. That's where everybody is on camera. It's Austin and myself. We'll see if we can get any of the other presenters there, and we just have a good time. We can tell some stories. We can laugh, eat dinner, have some fun. So I explained this. Oh, sorry, you're not looking at the screen. I explained this yesterday when I was on with the Melodome and FMX Radio, but I'll do it again because I want people to realize what we're doing, what Austin and I have put together, and why we put it together. Is we wanted to do something different. We wanted to make sure that we supported, if at all possible, the presenters. So to start off, we pay the presenters to present. They get a speaker's fee, we call it. And the reason we do that is because we think that the presentations are better quality, right? If you don't give anybody money, what are they going to spend time putting together slides or putting together a presentation for? I had tons of people call me over this week asking questions about so people are already working on their presentations all week or longer. So number one thing, like we said, we support them with a speaker's fee. Number two thing is we keep the price cheap. Even Dave Weiss has said, hey, I think you guys are too cheap on this event. And we said, no, we kind of discussed it. And we wanted it to be at a price that people could afford. If it's 3 times a year, that it's not going to break the bank. And we think we've done that at a $50 price for each event. And if you buy all 3 for the year, you pay $125, which means you get $25 off, and you're actually paying less than $50 for each event. Now, on top of that, we take half the proceeds and we give them to the person that brought you to the event. So if it's Austin and I that do that, if you select our name from the drop-down menu, then it would go to us. But if you are coming because Amanda Vollmer sent you, or you're coming because you came to see Jay Tolan present, then you just select their name from the drop-down when you go to purchase. I'll show you real quick how easy that is. And so right away, we think we've done something that we don't see other people doing. So we've supported the presenters in the way that if they bring anybody to the event, they're going to get reimbursed for that. And they also get a speaker's fee, so that we think that the presentations are better. On top of that, we keep your price low. And the other thing that we do is we provide a bunch of coupons. Now, I'm giving 50% off coupons for my consultations. I think Austin is doing some of the same. And we've got 10 or 20 more coupons that are coming from people throughout the community. So you actually save some money in other shopping. Now, again, I don't like to be that guy who says, because again, it does require you to spend money. But let's say throughout the next year, you were going to use me for a consultation anyway. By taking the 50% off coupon that you get with going to one event, you already save that money. It's equal. Basically, you're getting $50 off this and you're spending $50 on this. So what we wanted to do is make it eventually, and this is what our goal is to make it so people have to come, because there's going to be so many free things thrown in, or free ebooks, or discounts on this or that it makes it so that you want to come and you can't really say no to it. So that's our goal there. And then we also have a VIP pass, and like we said, VIP gets you the Q&A session on Friday night with the speakers. You also get the upgraded coupons, so you'll get a little better of a deal than the general. And I'm trying to think of what else does VIP get. They get that. Oh yeah, and then the after party, which is fun. We just basically, the other show will shut down and we'll just come back and do a Zoom with all of us. So last thing,
back on the screen.
No. I don't want you on here. No, I'm just going to show real quick the Truther.com. So it's really nice website. I mean, it's working well for us. If you go to Truther, you'll notice. Oh, you can't see what I'm doing here. Let me put this on the big screen. Where is it? This one. There we go. Nope.
The real poll question is, who did come out on top?
Yeah, I'll put that in next, so don't go anywhere. You don't have to. I usually do that though. I mean,
it would be cool if I want to jump back on here where we actually prepare, send each other what we're gonna cover, and go in like real deal.
What did you think of the layout for the most part? I mean,
I like it. I like it.
Good. I don't know why I don't have my left screen is not showing up. But let me add a thing. Oh, I'll just.
We'll say, guys, like,
put you back on for a second.
The summit's gonna be dope, bro. Because we have Dr. Kelly Brogan, Dr. Amanda Vollmer, Dr. Andy Kaufman. Are you kidding me?
How about Jay Tolan?
Avocado Wolf.
Jay Tolan.
Mike Winner.
Don't forget Jay Tolan.
Jay Tolan from Jay Tolan Media. We even got Alan just gonna destroy something. I don't even know what he's covering, but from Space Odyssey, it's just freaking melts your brain.
It's gonna be awesome. Who else we got?
Stellium 7.
How could you miss Iru Landucci?
We got Iru Landucci. We got Deepak and Foundering.
Foundering's hilarious. He's going to be good times. And we've got Justin Harvey.
Justin Harvey, who if you don't know, is the guy that went viral for asking Scott Kelly about bubbles in space and then calling out the ISS in the city council meeting.
Yeah, that's going to be awesome. So yeah, we think we put together a good lineup. Again, we're supporting all those people. We're trying to make it as cheap as possible for the attendees. And then it's got a nice website where if you go there, I'll show you in a second. But if you go there, you can see all. And by the way, we do another nice thing, which is if you buy this event, you get all the past events, which is pretty generous to say that you're going to get all 3 events that we've done so far. So Mount Meru and Equinox and Solstice. If you buy this event, you get all that. So all that together, I think you can't really lose.
Yeah, and like I know you were talking about the things that I'm going to offer for the VIP is I think because I'm going to end up kind of releasing this service where you can book basically bringing your loved one or friend or whatever that you want to hear about the earth, but they won't listen to you or whatever. If you can get them to have a conversation with me and ask other questions, or if you want to have a conversation with me about kind of like anything related to that or whatever, I'm going to give one of those away, I think, to VIP, right? In the giveaway.
Oh, nice.
Yeah, so that'll be the first one. And then the new Misfits merch, which is super fuego, bro. It's embroidered. It's really nice.
I like the sweater.
Like, yeah, I love it, dude. Super comfortable, like well-fitting joggers and hoodies that are embroidered. Anyway, yeah, the summit attendees will get like exclusive access to the Misfits merch, and I'm gonna put the coupon for the VIP all the way down to like the literal amount that I have to pay for them, like through the website. Dope. So yeah, I think that is the two. There's another thing that I'm off. Oh yeah, the etheric state. You can get crazy discounts on the blends. The VIP obviously.
Nice. I heard you guys. This thing went pretty well, huh?
Dude, it's so cool, bro.
I'm gonna do the next one. I didn't get a chance to get the blends, but I didn't want to do it without it, so I'll do the next one. I know you guys are gonna do them monthly.
Yeah, dude. Just and then tell me what blends you want, bro. It's like you should see some of the stories. People were like, I lost a ton of weight. I lost all these inches in my waist. Like my eczema's cleared up. Like my arthritis went away. It's like crazy. Not medical advice.
No, nope.
It's that crazy that we have to keep saying not medical advice. It's real. We're gonna put the testimonials together, but yeah, man, it's really cool, man. It's very exciting stuff. We definitely want to keep.
Oh, speaking of that, we have Stephen Dragon. So Stephen Dragon, I'm just looking at the schedule
Dragon,
for tomorrow. Yeah. Here's the schedule. We've got Foundering is going to open up with music until the doors open at 3. He'll go to 4. I'll do an opening. Justin Harvey comes after me. Then we've got Alan from Space Audit's going to destroy something. Stephen Dragon going to do an hour. Then Amanda Vollmer. Then David Avocado Wolf. We'll close this out, and then we have a VIP Q&A panel where the VIPs can ask anything they want of Dave Wolf, Dave Weiss, Stephen Dragon, myself, Austin Whitsitt, and Justin Harvey will all be doing that. So then Saturday we start early, music by Deepak for an hour in the morning. We start at 9 with Dr. Andrew Kaufman. It's going to be awesome. I actually know what he's doing too. It's going to be amazing. And Dr. Kelly Brogan is going to be from 10 to 11. Iru from 11 to 12. Mike Stellium 7 from 12 to 1. That's going to be dope. Then we have lunch and we have a raffle. So we have some giveaway things that if you're a VIP, you get 2 tickets into the raffle. If you're general admission, you get 1. And then we pull that. Last year we gave away $300 to somebody. Bunch of different things. Bunch of etheric blends. We have music by Deepak for the second half of lunch there. Mike Winter. We didn't mention Mike Winter. Mike Winter is awesome. If you don't watch Alphabetic, him and Barry Lando, who actually presented last time. Then Jay Tolan Media, Isabel Amiga. We didn't mention her either. She
Structured Water. Water is life.
Yeah, it's going to be awesome. And we've got Austin closing us out from 5 to 6. And then we've got comedy by Ian Cunningham. And both Austin and I talked to him in Vegas, and he just had us laughing. He had us laughing. And then when we, we're looking for a comedian, we said and he was so excited. The guy's been excited as could be. So we're looking forward to that. And then we'll do a dinner break, and then we'll come back for the VIP after party. Where it'll be Austin and I. We'll see if anybody else wants to come, any presenters, and we'll just kind of kick back with you guys and have a nice conversation. We'll let each person get a good speaking time, have some laughs, and I think it'll be a good time.
Okay. Yeah, the VIP after party is super cool because you get to just interact, and usually, like, I know Dave will hang out, whatever speakers might hang out, and you just all get to like hang out, behind the scenes. It's pretty cool. It's always very cool.
Very cool. So if you here's just
I think that right there is a thing that most people don't even know that happens.
Right.
They haven't even been telling people, and it's like we sit there for a while just hanging out with everyone. Everyone's got any questions they can think of, coming up with plans of what we need to do as a community and stuff. It's really dope.
So up here at the trueearth.com website, it's just very easy to go to audio. You can use this on your phone like a podcast player. So there's your Solstice 2 events, your Equinox 2 events, and your last year's Mount Meru. So just by buying this year's event, you get all these. You can listen to them at work, whatever. There's tons of content. Just go in here. You're going to basically go to anybody's speech. You want to hear David Avocado, you go there. Boom, you're in. I'm not signed in, so obviously I can't listen. And then you've got video. Same thing, right? You'd be able to, right here, the holder spots. These just tell you that they will appear on there tomorrow morning or tomorrow afternoon. And then this is True Earth, Mount Meru for last year. And then we've got Solstice and Equinox. And then in the extras, it's just a place where we put the links. So here's your spots already for the watch links. These will show up tomorrow. Virtual gift bags will show up tomorrow, and watch links for general admission. So that's basically the website. It's very simple, very easy to use on your phone. It's an app. You can go to the Apple Store and get the app for free. And you can actually check it out by going to the app, going to videos, and going to Mount Meru. Mount Meru is free for, I thought it was. Now, am I wrong? Oh, maybe you have to log in. I think it's free. You don't have to pay anything, but you have to log in. You have to have a user account. Anyway, but these will be free. You can get the app and try it tonight and listen to everything from last year's. We had Dave Murphy last year. We had Sean Hibbler last year. Marty Leeds presented. So it's pretty dope. So I'm excited about that. That starts tomorrow. And like I said, we'll give away a pass here in a few minutes. But yeah, hopefully everybody's going. How about put a 1 in the chat if you're attending tomorrow? Put a 1 in the chat. Put a 2 if you wish you could attend, but you can't, and put a 3 if you're a loser. Yes. Let me get you back on screen here, and then we will. I've got 2 questions. I don't know if you have anything you want to ask. I have 2 ideas. Well, yeah, I can't say them out loud yet because we're gonna have people start answering already. So basically, we'll have 4 questions, and you have to answer them pretty perfectly. Let me see here. Does people see if I put a chat here, or you can just see it and they can't? Let me see here.
Oh, so it's like a trivia question?
Yeah, it'll be 4 questions, and then I'll ask all 4. And as soon as I'm done asking, then the first person who answers all 4, like, it's going to be basically.
Should I make like some random, like pretty difficult to answer trivia question?
I think it's more fun that way. If it kind of is harder.
Okay.
And it's, I also told people to listen to. What is going on? Why is this on the whole screen? There we go. I also told people to listen to the whole debate so that they could get the answers. I hate Windows 11. There we go. All right, so let me.
I got an idea.
Okay, let me see if this one works. Now nobody can see me type this right now. Okay. How about this one? Oops, I lost my paper. There was. Okay, let's see here.
Do we offer a payment plan? Look at all these 2s.
There's a lot of 2s. Damn it. Okay.
You guys can come, man. I have faith in you.
You can do it. Look in the couch cushions. There's sometimes like 50 cents there, so you're actually only then $49.50 away. So it's not that bad. Yes, that one. Did you tell the people on your show that that Greg Locke's son was a flat earther? Did you say that?
Yeah.
No, you did.
I think that's why he's so angry about it.
Oh, it is. It made it all, and I was like, oh, okay. Then everything made sense. Everything made sense from there. What is going on?
Like, he's not, what is he like, going to let his son come tell him about the earth being flat when he's a preacher that everyone's supposed to look up to?
No way. No way. Okay.
Never going to say the earth's flat, bro.
No, he can't. Not now.
Jesus could float down and tell him it was flat, bro.
He'd say, that wasn't Jesus.
Yeah. He's like, no, you're lying.
You're misrepresenting Jesus. Like, no, it's me. No, you're misrepresenting. What did I do with those questions? I just wrote them down and now I'm missing
Yeah,
them.
you better check your phone. Did you hear his...
What?
The Bible verse is that everyone will see Yeshua when he returns, right?
What if your phone's off?
That's technology.
What if your phone's off?
No, it's not. What if one person doesn't have a phone, bro? One person?
Yeah, sometimes they don't charge
it.
Sometimes they don't charge it. I want to be there.
Yeah, bro. You better make sure you got to keep that iPhone charged up, baby. My wife is donezo, bro. My phone dies every 2 hours.
How about this one? How about that one? There's basically 2.
Oh, that was your question that's your question for the thing?
Yeah, I'm thinking, does that work? For one of them? Okay, that's number 1. And then what you can type me one if you have one in mind.
My question though, okay, so
don't say it out loud.
I was gonna kind of describe it and then ask them if they can like say what the name of it is.
Okay, we'll do that.
That's cool.
So that's number 2. Okay, and then was the answer like one word or multiple words, or be pretty
like 2 or 3 words?
Okay, but I'll be able to know. You think?
Oh yeah.
Okay.
Yeah. I'll type the answer in here.
Okay, yeah, do that just so we can both.
This isn't gonna pop up on the screen, right? I mean,
Not if you type it in the chat there. No. Okay. And then what was the other one? I'm trying to remember what. Oh no, that one's probably too hard. I'm trying to think of what else we could do. Oh yeah, we could. I mean.
Have you been in contact with Andrew Wilson at the Crucible? I met him at DebateCon. I have not been in contact with him. We're supposed to talk. We planned on doing something together.
Was that the guy that's the host of it?
Yeah.
He's pretty funny. I've seen him do a couple shows.
He's hilarious, bro. I'm not gonna lie.
Yeah, he's pretty. I don't know why either. He's just like I think kind of reminds me of my humor a little bit. It's like dry. It's kind of like sarcastic.
Like super blunt. Yeah. Did you hear the debacle that happened when he was supposed to be debating Mount Dilwaney or whatever?
Dillahanty?
Yeah.
No, what happened?
It was crazy, bro. He got super triggered. He called out like, people that deny basic biology, and he got super triggered.
Oh, really?
And left before it started. He actually got a speaking.
Oh, Dillahanty did.
Yeah.
Oh, yeah.
Like after his opener.
Oh, wow.
He was so funny though.
And you saw that? You were there when that happened?
No. I flew out. I watched. Oh, I was there, but I wasn't there. But I watched it on YouTube, and it was hilarious.
Okay, do you have one more you want to ask? There's my second one. I guess that's just somebody should get that.
Yeah, I can think of another one.
Okay, and then type the answer. Did you already type? Okay, I like it. All right, so we're going to ask the questions. There's 4 answers. It looks like the first one is going to be, you could do it in 2 words. Let me make sure I'm right on that. Yes. You could do it in 2 words, the first answer. So it should be, the first answer should be 2 words. Then the second answer should be about 2 or 3. And the third one should be 1 word, but you can come close to that. And then give me your last answer, Austin. And that looks good to me. Okay, and let me move.
Oh, your questions are easier than mine.
Yeah, that's kind of why get a hard one. I think it's more fun when it takes them a while to get it. We have to kind of give some clues or something. But I can't.
Those questions are kind of like I'm just gonna have to like say the question.
Yeah,
cool?
you'll say it. Yeah. That's definitely true. Okay, got you. And I'm ready. So the fourth one's about 2 words as well. Okay, so there you go. I'm going to ask the first question. So the first question is going to be, there's 2 ways that Rob said that they figure out the distance to the sun. Give us the 2 ways that he said that. Okay, next question.
I'm watching Rockfin.
Okay, I'm watching YouTube. Go ahead. No, we're going to ask all 4. So go ahead and give your second question.
Oh, we're asking them all?
They've got it. The answer has to be all 4 answers in a row perfectly.
Oh, wow. Yes. Okay. Okay. So there is a situation in cosmology where, based on the age of the universe being 13.5 billion years, based on the speed of light, the particles that would have had to interact for homogeneous energy and temperature distribution would have had to be directly in contact at some point, but they are distant too far away from each other for that to be the case. There's a specific name for this problem in modern cosmology. What is the problem that describes how there wasn't enough time for the particles to get far enough away in the universe in modern cosmology?
And that's about 2 to 3 words. And then my next one is, what did Rob say he would, if money wasn't an issue, what would he do to prove his theory? And you can actually answer that in 1 word. And then your last one.
Okay, this comes from the Richard Feynman, the Feynman diagrams. What is the name of the theory that people came up with to explain how particle physics cannot explain the magnetic field or electrostatics? What did modern particle physics come up with to explain away the discrepancies within their model in the magnetic field and electrostatics?
Okay, so Austin, look at this in the chat. That should be what you're looking for, right?
Yep.
Okay, go ahead. We're waiting for he's watching Rock and I'm watching. Call it out as soon as you see. No, that's not right. Awesome, Matt. Nice try. Remember, it's all 4 answers in 1 chat. and you will win a VIP pass. You can hang out with us Saturday night. Lorenz is not the right answer now.
It's gotta be 4 answers.
Mm-hmm. Okay, we got somebody who's got one. No. No. No.
No. Mine might be a little too hard. I can describe.
We'll give it a
more
second.
when
How long they can go. That might.
Here, I'm about to.
That's close though. Ben Pat, not too bad.
I'm gonna restart my camera real quick, but it'll just show this.
Okay.
Oh, wait a minute.
No. If you could not answer nonsense questions for us, so we don't have to look through those, I appreciate it. No, tractor beams is not one of the answers. It's a nice attempt though. Wait. No. Very good, Paul, but no. Yes, all at the same time. You're just going to answer all 4 questions. Again, the questions were, what did Rob say the 2 ways they get the distance to the sun were? What is the name of... You have to listen to Austin say it again. Nupa.
Yeah, just give me a second.
No, and then the third one was, what did Rob say he would do if money wasn't an issue? And the last one was the problem that Austin described.
Yeah, mine is there's a certain problem in cosmology. The second question is there's a certain problem in cosmology. There's a name for it where the particles in the universe are too far away from each other. They didn't have enough time going the speed of light to get that far away. It's called a certain thing. It's a certain problem.
Bukabusa, woman beating is not one of the answers. Unfortunately for you. Okay, so far nobody. QED, no, I don't think so. It's pretty close. Somebody came close. Bogan, there's 4 questions. I think that what you answered is 3. You still watching Rockfin?
Yeah, there's like no one typing.
Somebody says should not have let Austin think of the questions.
You said you didn't want them easy, man. We're out here, bro.
Yeah, okay. Well, we might have to make it a little easier, I guess, because people are not getting.
Well, I'll just I can give more hints about it though.
Okay, give more hints about the. It looks like nobody's getting the last one. I haven't seen anybody even come close.
Okay, let me come back over here. Let me come to.
Word salad is not correct. Let me ask again. So again, the first one is 2 ways that
Oh.
What happened?
Sorry.
I don't know what was going on.
Can you hear that?
Can we hear that? No. We do see you, like your camera. There's something in front of your camera.
Could you hear the you didn't hear the echo?
No.
Okay. All right, we're back.
Hold on, Adam. No, Adam got so funny because everybody keeps getting my 2 right, but the other 2 are not right.
Yours are easy. Okay, let me describe it a little bit more. Okay, the second question. Okay, it's 2 or 3 words. It is a problem in cosmology. Okay, it's classified as a fine-tuning problem. It is ironic. There are 2 problems. I'm making it really easy. There are 2 major problems in cosmology. They're both fine-tuning problems. One of them is called the flatness problem, okay? And the other one is blank. I described it earlier that there's not enough time for the particles to get away from each other. And it's also ironically parallel to flat Earth. First one is flatness problem. This is a different problem, and it's ironically also parallel to flat Earth. Again, it's that the particles couldn't have been far enough away from each other. They only would have gone so far away from each other.
I've now seen the answer, so somebody knows it now, but they still have not combined it with the other ones.
Okay, now the last one is particle physics had to come up with a different particle to explain why their model didn't work to explain magnetism and electrostatics because there was too much energy there. So they created something. Feynman gave a quote, and it's a specific one, by the way, but Feynman gave a quote saying that these things don't actually exist. They're not the input or output of any experiment ever. Their existence is questionable at best. It's simply a concept we came up with to make our equations work because they weren't working out.
Bogan, that's really good. You just the last answer should be 2 words, and you're right there. No, I don't think that's no.
Now I know people are going to get it now, though.
They should get it now.
They watch my stream at all.
Nope. 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 Multiple choice, please. No. Well, I basically gave you multiple choice because I already told you what answers were correct on somebody's name, so you should be able to get it.
You got to earn those summit tickets, baby.
Somebody might. No. No. That's not right either. Yes, that's right. And Ken and Carol, I don't know. You didn't answer enough.
Guys, I said it was parallel to flat Earth. There are two problems. The first one is flatness problem. The other one is the blank problem.
Bogan.
They both have something to do with flat Earth.
Bogan, put those together. You have it now. You just didn't answer all the. You have to answer them all in the same thing. Well, that one's no.
Someone's even like listening to you. They can figure it out. You know, they can like, oh wait, that person got it right.
Yeah, it's just easy. They should already get it. No. Well, no. Cheese is not right. Oh shoot.
Oh wow, but
shoot.
Someone's getting close. But they got them in the wrong. No, they got. Wait.
Which one?
Oh wait. The I don't know what the second word is. You see Bogan over here. I shouldn't have said it. Now people will know. But yeah, but Bogan anyway. I don't know what the second thing is, but they're getting close here.
Bogan was close. He got everything but the last one actually.
But the last one he got.
Oh wait. Wait, what? Yeah, Bogan. What is the second? Oh yeah. Okay, I'll give it to him.
Okay, he's got it.
Okay, Bogan wins. You because you got it in just separate things. You put Padilla, but I know what you mean. You mean parallax because you already said it.
Okay.
So Bogan wins with a radar, parallax, horizon problem, rocket to space, and virtual photons. That was the correct answer. Bogan Al-Sarid. Okay. Bogan. Do you have Telegram? If you do, message me at t.me/Jeranism. If you don't, email me right now at Jeranism. But it needs to happen like now if you could, so I can remember and not forget to give you your link. I don't know if you wanted to give another one away, Austin. There's one good. Oh, it's playing the.
What do you think about how I'm running the ad down here?
I like it. I got to put it on the full screen. That's awesome. Thank you guys. Yeah. So again, the correct answer was Rob said that they use parallax and radar were the two ways they get the distance to the sun. Of course, we have issues with both. And I don't even understand. How is he saying they could look at the sun with the stars behind it?
Oh, they just look at the position of the sun in relation to the constellations behind it.
Yeah, but how do you do that?
The sun has an ecliptic plane. It goes up and down basically throughout the year.
No, but I'm saying if he said you put two people on different ends of the earth and then they both observe the sun and look at what stars are behind it, but it's the daytime. So how do you do
what is going on?
Thank you for letting me finish.
My phone randomly plays videos.
That is weird. And then the second question was Austin's. It was the horizon problem. That's the one that was parallel with flat Earth. And then you've got the third question was rocket. He said he would take a rocket to space, which is funny because what he described is something that NASA could have done at, I don't know, any point in the last 60 years, which was take a rocket up and show a camera out the window and then show themselves and that kind of thing. But they can't do that. And again, I still claim, you guys know that there's never been, and I say this and you'd think that some glober would go find it, I've never seen an astronaut on the ISS go with a camera to the window at night. Never been done, never been seen. They just don't do it. And you would think after 21 years or 22 years in orbit, I don't know, somebody would take a camera to the window, but no, doesn't happen. I wonder why. And then the fourth question was, he would have to give it again because the answer was virtual photons, but it was basically they needed to come up with, he'll tell you, go ahead. And do you want to do one more or no, are we good? On just one, that's one ticket.
I can, but we're going to ask questions again. I'm going way easier this time.
Okay, let's come up with 4 more questions. You come up with 2, I'll come up with 2, and we'll do it again. I got to think of what I want to do, though.
We'll do stuff covered in the debate.
Haven't won anything ever, so this is great. Bogan, just tell me, are you going to email me or Telegram? Just write your next comment, please. Either tell me so I know to look for an email or Telegram, and then I'll send you your link pretty much right now. And then you just click the link and it will go to the True Earther site and give you a free VIP pass. All right. He's way wrong. What about the satellites that go out and see the Earth go around the sun and the stars not move? What? What about the satellites that go out and see the Earth go around the sun and the stars not move? I don't know what you're saying there.
Satellites don't go out and see the Earth go around the sun according to their own model.
I've never
be able to tell.
I would love to see that video. That would be great. Video.
Hey, bro, they don't understand relativity, bro. It's like, come on.
Well, I thought what was kind of glaring today is, and I'm not saying I could have done any better explaining it, but I don't think that they get why it, because the expanding universe is not observational. They're basing it off of calling redshifts, right? Which I don't even see how that works in a vacuum of space anyway. Redshift is because of the like sound
Mediums.
waves, they actually get compressed in the atmosphere, and then when it goes away from you, like an ambulance going by you, and then they stretch out. Well, the light can't do that because there's no medium for it to. Light should be the same speed in every direction, meaning if a planet's going, or if a star's going away from us, or a star's coming towards us, I don't really get why one would be blue shifted and one would be red shifted if light's the same speed no matter what. Doesn't really jive with me. It's because there is no ISS. Haven't you ever seen the cartoons? That was great at the end when you threw that in there. I was just getting ready to say, nobody even said anything rude about anybody, and your cartoon globe. I sound lame. They say they travel through the ball. Neutrino. Oh, neutrinos are great. I love neutrinos. Seen so many of them. I got a neutrino detector over here. 6 have come through since the start of this show, and 1 gravity wave. So that's pretty cool. Do snakes have armpits? Ooh, I think their whole body is an armpit, really. Let's see what else we got here. The universe is expanding. Thank you, Stanley Tools. Now, how do you know that? I mean, this is one of the things that I think Globers think, and they don't realize that just because Hubble came up with that idea, which is, and again, Austin is correct. The only reason they came up with the idea is because otherwise, then we're the center, right? Yeah. If everything's moving away from us, then they're like, oh shit, we're the center, or else everywhere looks the same and everywhere's expanding. And then, like Austin said, you need dark energy because you need something to push things away, and they don't have it. They don't see it, so they just made it up. It would be awesome.
You see how frustrating it is that it's like you got to say it 100 times to even a PhD astronomer or something? Like,
well, even like Fight the Fat Shirt, it's like he just now realized east and west are circles. What has he been doing for 8 years? Like, how many times do we have to say this? And he's just like, nope, no, it's straight line. You can walk straight in any direction. You're going to come back to it. No, it's not the way it works. But it's just funny. It just tells you they're not listening to us at all, which I don't listen to them either. So I guess it's not really saying much.
I listen to them, and that's why I can pop these right here on and do better than they can.
Oh, now you're ready. Let me see if I ask you. So explain to me the how you're going to account for this dark energy, dark matter. Hold on real quick, though. I got to ask this. Isn't it the equivalent of if they said to us, well, guys, how does the sun and moon stay up in the sky? And I said, oh, it's dark lift. And they said, what is that? Show us some evidence. And I go, well, we know it's there because the sun and moon are up there. So therefore, dark lift is we just don't see it, but it has to be there. I mean, they would never allow that. They would laugh at us. They would just laugh at us. But their model, no, it must be right. It must be good. All right, let me start
doing that dark lift.
Yeah, the dark lift. I saw somebody actually give that as one of the answers. It's hilarious. Trying to think of a good question here. Maybe we'll go with something more hilarious. Something.
I'm pretty sure they're gonna know my question I put in there. Like,
you mean when you ask
I
it?
think I said it like 500 times.
Oh wait, you already told me. You already wrote one in here.
Put a question in there, yeah.
Okay, wait. But didn't you do more than that? Oh, okay. I got it.
I don't think so.
I got you. No, there other things that were brought up. Okay.
You don't think they'll get that one either? They'll get that one.
They'll get that one.
Should I be more descriptive? I think they'll get that one.
They should get that one.
Let me think.
Okay, I got one too. Let me think here. How about this one? Speaking of that, we'll go with this one. Then it gives the answer to the first one. No, never mind. Don't want to do that one. Well.
Okay, I got an easy one.
That one?
Yeah, that's good.
Okay.
You're going to get really bad spellings.
That's right. So that's the first two. We got 2 questions down. We'll get another one. What did he say? Do you dye your beard? It looks too perfect. That's hilarious.
Yes, that was weird. I don't know.
You could tell it's loose because it's so tight. FTV. No conspiracies. What does that mean? There is no conspiracies. What do you mean? Man, Stanley Tools. Who is this guy? Real satellites. No conspiracies. Yeah, we wish that was the case, but if you did a little bit of research. When are you guys going to get the truth out there? When? What did we do tonight? What are you talking about? Kind of a weird question.
How are you going to?
He's going to be in here in the chat. What do you mean?
You're telling us we're not doing good enough.
It's all right.
It may have been a good faith question. All right.
You never know. I do have people asking me, is it fight the fat shirt or tight shirt? I'm not really sure.
Tight shirt. Fight the tight shirt.
Okay. I think that came around after, but that's all right. We don't know how much light is redshifted because no one know its frequency at the time of emission. Beautiful. That is exactly right. You're exactly right. That is right. So they assume they know, but how would you ever know that? You have to know what the frequency of the light at its source is, and then you could say that, but you don't know that. Great point. I don't know how to say your name. It's like hey, something like that. A bunch of letters or symbols.
I'm gonna say, why haven't you read all the super chats?
I didn't.
I'll read them. Adam, thank you for the $5 super chat. At Whitsitt, you forgot to yell, you're AI nanobots. That's the best way to win a debate. Proven. This is in reference to yesterday?
Yeah, I think so. He just started yelling at her until he kept telling me we were AI. AI had taken us over. They didn't want us to know the truth, so we're gatekeepers. Gatekeeping the
that dude started screaming, calling you AI. I'm like, bro, this is awesome entertainment, man. This is great TV.
That's what everybody said. Everybody's written me like, hey, last night was so much fun. I'm like, I left the office like just livid.
Yeah. You looked like you were miserable.
Oh,
I was happy.
Still my
wife.
And
then Karen just screamed back at him at one point.
Thank you. Yeah, she's like this. Ah!
Yeah, I was crying, bro.
Oh my god.
All right. Wood Floor Alchemist, thank you for the $5 super chat. Professor, how honestly do you consider your position may be wrong? My brother, he has been gone for a minute, but I don't think he even conceives of that as a possibility. John Marco, thank you for 279. 6 million lie. No way, how dare you? It was 6 trillion. Kryptonian, thank you for the $5 super chat.
Okay,
a man's gift will make room for him. Completely understand the speaker's feet. Did you already read these?
Well, I went up to a certain point. I think the Dearth was the last one. Do you see
okay, completely understand the speaker's fee. Yes, the only way that we're able to put these people together.
Well, they might come if we didn't, but at the same time, it's just easier to approach them. And then also, we want to support great content creators, and we want good presentations. And if we just asked everybody to do it for free, then I wouldn't be surprised if people showed up with like no PowerPoint and just kind of like
no real effort and like
I wouldn't be surprised.
And plus, you want to help out other truthers anyway. I don't know.
Okay, Bogan, I got your email, so I will get that back to you right after this show. And let me see. Was that the last one? Was Durst the last one, or is there more?
Welcome to Flat Earth, Professor. Snacks in the back. We already read that one, so
that was great. Yeah, that was great. And I had to, as soon as I saw Durst super chat, I had to go get Curb the Enthusiasm ready. Okay.
It's funny they try to say Dave's not a flat earther. It's like, well, he's tricked himself, man.
Yeah, he's definitely convinced himself. And there's never even been like an inkling from that guy to me that he has any doubt in the world. Like never like well, I don't know about this. And, nothing. It's just like absolutely 100%. It's already known. It's like, oh, by the way. So the other thing that just came up recently that I think is huge is Elon Musk on Joe Rogan says to Joe Rogan that he's talking about plane flights, and he says it's a he gives the equation, but basically says the higher we go, the faster we go. And once we get to a certain height, we can go past supersonic because you don't need to worry about the atmosphere anymore. And it's like, nobody ever says that. So it's like, he's giving us the answer of how they fly in the South, which is, he says that it's, God, I want you to hear it, because what he's talking about is that there's an equation for drag and there's an equation for, what's the other thing that they use? So it's drag against, I want to say lift, but that's not, is it lift?
Thrust.
Yeah, thrust. Okay. But he says that it's one's a squared, it says to the square, and the other one is linear, and square beats the linear or something. I just sent it to Dave because.
So then let's figure out the freaking altitudes of these southern flights then.
Yeah, for sure. Let me listen to this. Listen real quick on this. I'm going to fast forward a little bit because I think he talks about some other nonsense first. What happened? Okay, that's a nice thing. Here we go. Just listen to what he says here. I don't think this has ever been said like publicly that I've ever heard.
The interesting thing about an electric plane is that you want to go as high as possible, but you need a certain energy density in the battery pack because you have to overcome gravitational potential energy. Once you've overcome gravitational potential energy and you're at a high altitude, the energy you use in cruise is very low. And then you can recapture a large part of the gravitational potential energy on the way down. So you really don't need any kind of reserve fuel, if you will, because you have the energy of height, gravitational potential energy. This is a lot of energy. So once you can get high, the way to think about a plane is it's a force balance. So the force balance. So a plane that is not accelerating is a neutral force balance. You have the force of gravity, you have the lift force of the wings, then you've got the force of the whatever thrusting device, the propeller or turbine or whatever it is, and you've got the resistance force of the air. Now, the higher you go, the lower the air resistance is. Air density drops exponentially, but drag increases with the square. An exponential beats a square. The higher you go, the faster you will go for the same amount of energy. And at a certain altitude, you can go supersonic with less energy per mile, quite a lot less energy per mile than an aircraft at 35,000 feet, because it's just a force balance.
Joe Rogan's like, huh? I'm too stupid for this conversation. So, I mean, to me, I think what is being said there is kind of what I've always thought is that if you are going higher, then you would think that you could, and he said, the higher you go, the less energy you need for the same output or the same speed. So you can go faster, higher for the same output.
Yeah, of course. Yeah, and it makes sense. This guy's like, no, because you'd have to go, yes, Jeremy, but you have to reach altitudes that commercial aircraft can't reach. What are you talking about, bro? We have commercial aircraft that go way higher than 35,000 feet.
There's private jets that go like 48,000 feet.
Yeah, what are you talking about? He's saying that once you get above 35,000, you can go faster with less energy.
What people need to realize is that this is a deception. So don't say like, oh, but they say that. Well, what we're saying is that wouldn't it be quite easy for them to do this? Like no pilot would know. No pilot even needs to know. And actually, there's probably only a couple pilots that fly that route anyway in the South.
And I mean, you would just be going at a bit of a higher altitude. They could even have like a cover story for why you have to do that. I mean,
well, sure, but that's all figured out by the computer. The computer decides what flight level you go to. I mean,
yeah, but they can see it, right?
Yeah, I would think so. I mean, it's obviously there's an altimeter in there, but yeah, I mean, if they went up to 45,000 feet, I don't know why a pilot would be like freaked out about it. They would just say, "Oh, we're going higher. I guess there's no wind up there. Or there's more wind." Well, there you have thinner air. Yeah, well, so think about it. What is breaking the sound barrier, which causes you to go supersonic? That's when you're going through the atmosphere at a certain speed. So why would it be that if you get up to 50,000 feet, and how little atmosphere is there? Isn't there like 5%? So like really, are you breaking the sound barrier by going through that little of air? I don't know.
This Charles person is trying to go down swinging. That's so funny. So way higher, no, and 45,000 feet, not that high. Okay, what altitude is Elon Musk talking about when he says he's going to make an electric plane? Do you happen to know how high it's going? It must be significantly higher than 45,000 feet. But no, he just said higher than 35,000 feet. It's an exponential drop off. So whatever, bro. I mean, I'm just saying that they admit they can go 45. They admit they can go up to 60,000 feet.
Yeah, I know that like private jets fly a lot higher.
What's the thing that flies at 60,000 feet? There's something that flies at 60,000 feet. So
the Concorde or no?
Yeah, isn't it 60,000?
I think it flew that high. But I just never thought about the idea of the because they say you can't go supersonic in a
60,000 feet,
right? Oh, Concorde did.
Yeah.
So I'm just wondering.
So anyway, the point is that they can fly higher. They'll be able to go faster. Plus, you can clutch the jet winds, which actually the jet winds are. Did you know this about the jet streams, bro? That they actually go in different directions at different altitudes.
Even 1,000 feet up could be going the other direction, 100 miles per hour. 1,000 feet down, 100 miles per hour that direction. That's crazy.
So I mean, and it could be going super fast high up. They just go catch the crazy fast jet streams high up, and they don't have as much of air resistance. They could definitely go crazy fast in the plane.
Because what we're supposed to believe, I guess, is that the Concorde, which went 1,400 miles per hour, they had to retire it or whatever, and we just believe now that planes can't go faster than 500. If you can get past the fact that they can go faster than that, then you've explained the entire southern flight routes. And there's not very many southern flights. There's only Auckland to Santiago, Sydney to Santiago. I think that's basically it. They don't fly much other ones. There's no Perth to Buenos Aires, which would be a great proof because it goes right across the South Pole. What's the other one that would do that? Auckland to, I think it's Auckland to Buenos Aires too.
Bro, this Charles guy, man, like,
what's he saying?
He's talking about 70,000 feet. Did he say that? I mean, maybe he did. Okay, Concorde flew at 45,000 feet.
Right,
it flies at up to 60,000 feet. Admittedly, the Concorde flight goes up to 6,000 feet. So if he's talking about 70,000, who knows what they do? And I don't know if he said that. I just don't understand what this guy's point is. Like,
I don't know what he's saying. So flew for
point is that the plane could be going at a higher altitude, catching a faster jet stream that could be faster at a higher altitude, and you could be going a good amount of distance in the south, but it would only maintain its airspeed relative to the static pressure around it. You wouldn't even be able to really know. And it just is given a final output. You could definitely travel way furher in the south.
So here's the
people
other
think
thing I
it's
don't
one of the
understand.
most rare flights that exists.
So the reason that supposedly when rockets go up, we don't hear a sonic boom is because whatever direction you're going, that's where the sonic boom goes. So if a plane is gaining altitude when it breaks the sound barrier, then this sound wouldn't be heard on the earth. So I never understood why people are like, oh, you can't do a sonic boom on the ground because it would interrupt people. Well, not if you're going up. If you're going up, then the sound would go up. So, or the sonic boom would go up. So I just feel like there's a bunch of little things that people don't.
People just say whatever whatever they want to make up, and if you make up something but you're defending the globe, then it goes unchecked by everyone else.
Right, you can just get away with anything.
But if you say something that's accurate but less known as a flat earther, then everyone ridicules you and says it's wrong.
Right, we're lying about that. You're lying. There's no, when I talk about the Vendée Globe and I say that the those boats end up doing like 8 knots, but then when they're in competition, when they get speed records or their speed is like 35 knots or 30 knots, and we're just supposed to believe that when they're in a race to go around the world, they can only do 8 knots, and people are just like, yeah, that's totally normal. I'm like, why can that boat do 35 knots then? Oh well, I mean, Toon was like, Jaron, you're not even calculating them sleeping. I said, they don't fucking sleep, Toon. He's like, yeah, right, they can't travel around the world in 100 days and not sleep. I said, you go watch those guys' blog. Those guys sleep 5 minutes every hour. That's how they do that. That's how they do that race. They sleep 5 minutes every hour. They have to train themselves to do it. It's like a sport. So again, they don't even sleep. So the boat is always going a constant speed. It's got an autopilot, and you would think that that boat could do way faster. If it's going around 60 degrees, what is that, like 15,000 miles supposedly? I think.
Yeah, let me expose it. These are like the people who are lying so much in the chat. I'm assuming that they're Globers, because only Globers lie incessantly and obsessively, and then get exposed.
The sonic boom radiates all directions in the atmosphere. Then you go find me one rocket launch by NASA, by SpaceX, where there's a sonic boom. You can't just say that, dude. I mean, I've watched enough rocket launches to know that there is no sonic boom at takeoff. The sonic boom happens on landing.
Let me expose these people. Charles, you're lying. We're going to expose you again, right? Whitsitt, no one catches the jet stream. That's crazy because they admit they catch the jet stream.
How do planes
go?
And
they've been documented to go over 800 miles per hour in the north, catching a jet stream as a ground speed. You can look up mainstream articles where they admit that the plane went over 800 miles per hour by catching the jet stream. Autopilot, if you actually even knew the physics of the plane and how it was engineered, autopilot automatically tries to ensure the least amount of air resistance, so it would automatically catch the airstream. Secondly, no jet streams are at 60,000 feet. 40,000 feet is the max. Stanley Tools, you're also making stuff up. You can just easily Google it. Yes, there are jet streams that can reach altitudes of 60,000 feet. There are 4 of them that constantly circle the Earth from west to east at an altitude of roughly 18,000 meters to 60,000 feet.
I can't imagine being like these guys. Like,
why are you guys lying?
Why are you like that?
Why
would you say Stanley Toole says we Globers have been giving proof to academia hundreds of years, and it's been accepted for hundreds of years? Has any of your stuff been accepted? This is all we care about. Well, bro, you are leading yourself to deception. Do you realize that? That just because they tell you a story and you're like, you haven't done shit, by the way, Stanley Tools. You haven't done any of these tests. You just trust men. We're actually exposing.
Well, think about this though. We just thoroughly exposed. He said it doesn't go to 60,000, only goes to 40,000. I just objectively.
What, the Concorde?
No. Oh. He said that there are no jet streams above 40,000. You can easily Google it, prove he's wrong, and he's like, "Yes, what's it? LOL. The truth is lies." No, you're just lying. Just like the Charles guy lied 3 times in a row, got exposed every single time. Think about that. After they get exposed, because they're just anonymous weirdos on the internet, they'll just keep on lying and gaslighting.
Yeah, I've actually heard it's like a job that they do. Like I've read about it. It's where it's a certain tactic where you challenge
Try to
somebody
make
with
the
what
other
they're saying.
person go crazy.
Yeah, you just keep challenging us, and then as soon as we prove that, then just go to the next thing. And it's like, we'll just keep us, doing this all night. Well, no, that's not right. No, you're wrong. And they just they get off on that. All right,
They're saying I'm lying, but we could just literally, I could just show the screen, right?
What are we
I'll just
lying
show,
about?
let me show the screen real quick.
Why don't you tell us what we're lying about? I want to hear that. Why would we lie? It doesn't make any sense. What good would lying do? I know you guys get away with it, and it works for keeping the globe in people's minds. But for us, what good would lying do? How is that going to make the Earth flat? Because we lied about it? That doesn't make any sense at all. Okay, go ahead. You are sharing.
Okay, so there are 4 of them that constantly circle the Earth from west to east at an altitude of roughly 18,000 meters to 60,000 feet. Here's your little AI telling you, yes, there are jet streams that can reach altitudes of 60,000 feet. That's highaltitudescience.com. So I guess that it's just lying, right? Okay, let's go ahead and check the next lie. How high? There it is. How high does Concorde fly? The Concorde could fly at nearly 60,000 feet. You guys said that wasn't true either. So, okay, now let's check out the next one. Plane goes over 800 miles per hour, jet stream.
Nobody catches a jet stream.
Yeah, no planes catch the jet stream. A Virgin Atlantic plane flew at 801 miles per hour from Los Angeles to London, reaching its top speed over Pennsylvania thanks to a 200 mile per hour jet stream. That's ABC 7 New York, and there's like 57 articles about it. So every single one of your claims were wrong. You said we were lying, but you were lying about every single one of them.
Now, Austin, look up fastest jet stream and watch when it says it's in the south. Even though the record's in the north, why is the fastest jet stream in the south? Why aren't your planes in the south using the jet stream? If you do the math, a 6,000 mile flight in the south from Auckland to Santiago is 6,000 miles, and it takes it about 12 hours. So it's doing 500 miles per hour. Okay, great. That's what planes do, right? Except for the fact that there's a 200 mile per hour jet stream down there. So your planes are actually doing 300 miles per hour and then getting a boost and going 500. That's what you have to believe you live on a globe. Whereas what we believe is that the plane's probably going 750 miles per hour. And if it's going 750, now do 750 times the amount of time, which would I say was 12. So 750 times 12 gives you a much longer flight. 750 times 12. So instead of actually going 6,000 miles, what if that distance is actually 9,000 miles? And nobody would even know. And there's no shipping routes down there. The container ships don't even go across the Southern Ocean. There's no cruises that go across. There's ones that go New Zealand up to Phuket, up to Easter Island, to the Tonga, and it takes like 50 days. But why isn't there just a cruise that goes right across the bottom? Well, it's because that distance is a lot longer than we're told. But again, you have to figure that out on your own. You can't just listen to us. We came up with that on our own. We saw the problems. But then why is there so many things that lead this? Why is there no undersea cables in the South? Why is there no cruise ships? Why is there no... When you start seeing too many of these things, and then you see what Elon Musk said, and you see what planes can do, then you realize pilots don't even fly the planes. From there, you start to put 2 and 2 together. All right,
it's so funny because you do stuff like that. So Charles starts moonwalking, the other guy disappears.
What I meant was, what did I use?
No, Whitsitt, why do you flirts have to lie so much? Okay, here's you just getting objectively refuted. That's not what I said. Oh, I'm gonna go.
I don't understand why people would think that we would lie. What good would that do? Like, give me another 3 days on YouTube till I'm exposed? I don't get it. Okay, we got that question, and then you have this one. Oh, yeah, that one. Ooh.
Oh.
Okay.
All right, I'll stop sharing.
Okay, I get this back up. Thank you for telling me that, by the way. And me. All right, and let me actually move myself over here. Where am I? You still use
the camera for whatever reason, it starts delaying after a couple hours. It's kind of lame.
Starts delaying? What camera do you
use?
I'm
using this this. Have you ever heard of Video Ninja? And you can use your iPhone for your camera. But
oh yeah, I have heard of something. Nathan Stoltman uses something like that.
Maybe there's a better one because this one starts glitching.
Is it free?
Yeah. VDO.
That's probably the problem. You get what you pay for most sometimes. Unfortunately,
I'll pay for one. To be honest.
Yeah, I've done that a couple times because, like, I always get people who say, like, man, I've had so many problems downloading this or downloading that. I was like, I've never had that problem because back in like 2016, Bob Nodell told me, oh, do you want to use this? I have a license to all my tube. And I was like, what is that? He's like, oh, you can download from any website. Just put in the link and it downloads the video for you. So, and it's only like $70 for a lifetime membership or something, but I've just never had a problem. I've always used that every time I need a video. Just boom, you can put in anything. You can put in Daily Motion, you can put in Vimeo, you can put in YouTube.
And what is it called?
Wondershare All My Tube.
Oh,
And
yeah. Bob put me on that a few years ago.
Yeah, so it's like, it's just funny because like I would have never paid for that. I would have tried like everybody else does to find the free one, and then the free ones always stop working or they're like full of bugs or ads or something. All right, so we got that question. What did you put as the third one? Oh, I like that one. Okay, good. That's 3 words. Good. Okay, and then my last one is going to be
Charles, we're gonna pray for you, brother. I hope you can get a girlfriend and maybe you'll start doing some push-ups. You know what I mean? It'll be okay, bro. I mean,
Austin, how old are you? Can you type your age in there for me?
Believe the earth is a globe, my brother. We don't really care. We don't really care. Just I had to expose that you guys were like kind of spamming the chat with lies, you know.
And you can believe it's a globe. We're not trying to. If you want to believe it's a globe, then we kind of know those people. Those people are just going to keep believing that no matter what. So go ahead. You don't. We're cool with that. Austin, type in your age right there for me. This is gonna be my final question. It's a really good one.
Oh,
I don't even know what it is. It's gonna be too low. I'm gonna be really upset. Okay, that's too low. All right, let's go with. All right, first question is. Oh, you go with the first question. It's yours.
all right.
Get ready. We're gonna do giveaway one more VIP pass. And you just need to again answer all 4 questions in order. We'll tell you how many words or about how many words it is. Okay, I got the chat up. Go ahead. Your first one.
All right, reminder, you got to get all 4 questions right. All right, first question. What did I use to debunk the curvature of the earth in the debate tonight with Robert Parks? Okay. What did I use to debunk the curvature of the earth claim in the debate tonight?
And the answer would be probably 2 words. Okay, and then who shot radio waves across the Atlantic in 1901? That's a 1 word. You can get the answer in 1 word. Okay, go ahead, third one.
What's the name of the intro song that I recorded that mentions Israel?
Okay, and that should be how many words?
3.
Okay, 3 words. And then the final one is the combined age of Austin and I. Gotta get that right. That is a number. 2-digit
Nice, that's
number.
a good question, yeah.
2-digit number. All right, so again, the first question was, what did he use to debunk curves? Second question, who shot radio waves across the Atlantic? Third question, what is the name of his song? And last question is our combined ages. All right, I'm looking at YouTube, I believe. Okay, there we go. Everybody likes to answer.
Got to get all 4 answers. Don't just type one of them. And what good is that going to do?
I don't know why they do that. Does your car GPS show curve? Okay. Charles is comedy gold. Jaron, why would you lie? Did you really just ask that on a monetized channel? Yeah, because I don't understand how long you think I can get away with that. Like, what? I mean, I don't understand. You think I've just been lying for 8 or 9 years, and people just watch me and they're like, yeah, Jaron just lies. We don't even care. I stopped watching people who lie.
Lie about what?
I don't know. You didn't even tell me, but he just says.
Oh, just lying.
He says you would lie. I guess I would lie because of a monetized channel. Then, if what you're saying is true, if we're going to put that on me, then what do you think about every single scientist that gets paid more money than me? Neil deGrasse, Bill Nye. Then that is true for them as well. Then they are lying because of money they make. If I'm lying because of the couple dollars I make, then every scientist is lying because of the money they make, according to you. That doesn't seem very logical to me.
Some people got close.
Hold on.
Level Earth got close.
Wait, where am I at here? Oh boy.
Pine Big Selling got close.
Wait. Bogan is answering again. Bogan, stay out of this. You're not winning another ticket. It's a one-time winner only. God, this is moving too fast. I can't keep up. All right, I got to start at the top so I don't miss somebody. Okay, that
you guys are missing. Okay, repeat. I'm going to repeat the question because some of you are missing one of them.
Okay.
What did I use to debunk the curvature? That's number 1. Number 2, who shot radio waves across the Atlantic in 1901? Number 3, what's the name of my song? Number 4, our combined ages.
And if you type it and you don't hear us calling out, it's because I'm actually going down the list, so I might be a little bit behind everybody. But if you answered it first, you will win.
I'm looking. No one's won, I don't think.
Wait, this one might.
Oh, well, Rockfin, they're not answering, so I'm looking at
Kevin Samuel. Kevin Samuel. Oh, no. I'm wrong.
You got the age wrong.
Now somebody's going to get real quick.
A lot of people have got the first 3 right.
Our combined age is not 47. That would be
JJ.
Pretty
got it.
Who did?
JJ.
Where's where at? Why don't I see it?
He's at the bottom.
Okay, I'm going down there. Nobody got it above him? I don't see.
I don't think so.
Wait, JJ on the bottom of what? YouTube?
Yeah,
Oh,
yeah.
I see it. Okay, you got it. Okay, I'm just gonna make sure it's not JJ. It looks like you win, and he's also a supporter of. I mean, he's a
sponsor
of the show. But that's great. Let me see. Okay, just making sure nobody got into Buddy. Nope.
Yeah, I don't see anyone else.
What
A
about?
bunch of people just got the wrong number.
Oh man, Justin Johnson came close. He put
75.
No, he put 1 micro transmission as the first answer. Then he put 2 Marconi, 3 in the field, 474. So, but he didn't get. I don't know what 1 micro transmission is.
Oh, he's probably trying to say microwave transmissions, which is dangerously close. And I did kind of mention,
But that's not what you used to debunk Curve, was it today?
No, I specifically invoked the radio.
Okay. All right. I'll leave you all here to fester in your insanity. Oh, it's insane. I'm so insane. I don't think the Earth's moving. And you are the sane one who thinks we're flying 1.2 million miles per hour because some dudes told you. You're right, Stanley. I'm insane. I'm insane for thinking that the Earth is exactly as I feel it. I mean, so crazy. I'm insane.
This guy's a goober, man.
Can you imagine just believing right now that we're flying 1.2 million miles per hour because some guy said the math works out?
Can you imagine believing that and then feeling the need to go tell everyone else?
I know, and then calling them idiots. You fucking idiot! Why don't you sit here and fester in your insanity?
Yeah, that would be so weird, bro.
That is great.
Yo, Sagan, you think we're young, bro?
All right, well, yeah, I guess that is correct. JJ, you win. Wait, JJ wins.
Saker just hit us with 58, bro.
58, nice. All right, I'll take that one.
Nice.
No, I am a too old, and he's too young.
I'm too old.
God, you're almost like, you're what, 6 years older than my son? That's crazy. That is crazy. That kid, when he was here, dude, last, he smoked a quarter in a night. A quarter. I went to the store, went to the club, bought him a quarter. He's like, you want to smoke a blunt with me? I'm like, yeah, roll it. I'll go smoke a couple hits. Smoked a couple hits. The next morning, he's like, when we go back to the club? I'm like, I don't know, whenever you run out of that. He's like, oh, I'm out. I'm like, what do you mean? He's like, I smoked like one night. He's like, you used to smoke. I'm like, dude, I have never smoked a quarter in a night in my life, even with like a bunch of friends. This guy's doing it to his dome. It's like, oh, I just rolled 4 blunts. What's the big deal? I guess nothing. I don't know. You're not getting another penny from me. How about that? All right, good. All right, guys, we just
got 44 and 33.
We're gonna do a pre-show tomorrow, right around noon.
Yeah, I'm done.
Do you know how to do? It's possible to do a simulcast. Yeah, we would just both share.
Yeah. From
the Zoom, right? I think it's possible. All right, so we'll do that tomorrow at noon. Hopefully, you guys join us, and then we will end that in about an hour, and then we'll go over and have a fun summit. So we hope to see you guys there. It does support Austin and I. It supports the presenters who are doing great work. It feels good for us too to be able to, pay Amanda Vollmer some money. It just feels good. I've learned so much from her. And dude, Amanda Vollmer is awesome. She doesn't have to talk about flat Earth, and I'm in her groups and stuff. She's just constantly posting about flat Earth, and she doesn't have to do that. Like, she's got her avenue. So I think people like that are just impressive because she just knows it now, and she's just.
She's not backing down.
Yeah. No, because there's people under.
Same with Tom Cowan's going to be like that.
Yeah, he's coming along too, huh? So I'm excited to hear Kelly. I'm excited to hear.
Kelly's also super cool. Yeah,
I'm excited to hear about structured water. Lots of things. I want to see Jay Tolan. I've never seen Jay Tolan give a presentation, so I would love to see. I would even like a best of. Here's my observations. Here's my infrared stuff. Here's the best of.
Yeah, for sure.
It'd be huge. All right, sounds good. Looks good. Let me make sure there's no more.
Oh yeah, guys, go to the summit, trueearther.com. It's going to be epic. And we got all kinds of giveaways and coupons, and you'll get the free little consultation type intervention service thing with me. You'll get the free Miswits exclusive Miswits merch from me, and you'll also get discounts on the Thick Lynch for the next fast from me, and lots of other VIP and general coupons. And you'll get the VIP after party for VIP, as well as the Q&A panel. So you'll get to ask the questions directly, and you get to just be in the room with all the people anyway. And your questions always get prioritized. And yeah, you get to kick it with everyone afterwards. So
very cool. All right, looking forward to that. Hopefully, you guys are there. And again, you can buy it tonight, and you can start watching last year's stuff or last summit stuff.
Yeah, I mean, honestly, what always happens is people end up reaching out to me. And they're like, "Dude, I was listening to David Avocado Wolf or Amanda Vollmer or whatever, and I realized that I needed to get this, this, and this." And they got the hookups on those things, and they're like, "Oh, bro, the summit paid for itself, and I learned a ton of stuff." Yeah,
And maybe I don't know if we're going to do it. Yeah, we'll think about it. But we also are offering on that site. By the way, Conspiracy Music Guru is on. I'll just show that real quick, just so people can see on TrueEarther.com. Well, shop.TrueEarther, but you can get there from TrueEarther.com. We're selling his 5-album set, which is every song he's done, for $23. You get it all. That's available on here. Just so you know that's there. And then we already sold 2 of these, Austin, the dinner. So I don't know who's going to be there at these, but what we're offering is Austin and I will join you for dinner on Zoom, and you can bring whatever friends, family you want to dinner at your house, and then we'll talk to them about Flat Earth while we eat. So maybe you've got a girlfriend, boyfriend that you want to have a conversation with Austin and I if you want to do that, or maybe your son or daughter, maybe your brother, sister, maybe your friends. Bring 10 friends to your house, have dinner, order pizza, and then talk to us for an hour. And that's also on the site here. And we will be out of here. There you go. So here's the items. We've got general admission and 1 year. Again, even though $50 is cheap, if you buy the year, you get $25 off. So you'd get the next 3. You would get Mount Meru, you would get Solstice, you would get Equinox, and then you get everything in the past for just $125. Or you could buy all the past summits for $20. Don't know really why you would do that. You can just pay $50, get this one and all the past. Then there's the VIPs, same deal. And then here we've got Conspiracy Music Guru. You can get that for $23, and a Zoom dinner party with Austin and I. Whenever you want to do that, you just buy that and then reach out to us, and we already got one scheduled. So, and then just to show you one of the cool things you can't really get this much other places is if you look at all the crypto that we accept. So you can do any of these different cryptos. So if you've got some, I don't know, Monero sitting around, some Nano, some Solana, some Bitcoin Cash, some Ethereum, whatever, DAI, wrapped Ether, Shiba Inu, whatever it is, you can go here and easily use those coins. So if you don't want your name on any lists or something, go over here, click Monero, pay with Monero. Nobody knows it was you. You come to the event, you have a good time, and everything's fantastic. And then once you get in here, you hit continue, and this is where the drop down. Whoops. Oh, this isn't an item that. Sorry, I was in a support. I got to do this one. There you go. So any item that is the Mount Meru conference, once you go continue, pick your payment. Let's go DAI. And then you'll see you got to put in your email address. And then right here is where you're going to get this drop down box where you choose who you want to support with your payment. We give half the proceeds to these people. So you can also hit split by everyone, and then we would just divide that by 15. Austin and I don't even include ourselves in that. So you would be splitting it between all the presenters. If it's us that you are coming for, then you can select my name or Austin's name from the list. Otherwise, if it's somebody else, then pick somebody else. So everybody's on here, and there we go. All right, guys, we'll see you tomorrow for the pre-show at around noon on both of our channels. Anything final, Austin? Are you good?
No, it's exciting, man. I always get super excited about the summits, man. It's like a very uplifting energy, kind of pushes you back through to the next one.
Totally agree. We're going to play this, and then we'll see you guys tomorrow. Till then, peace.